Hello everyone, so in this video I'm going to discuss center of mass and rotational motion. So usually most of the students they face difficulty in these chapters, and so I'm going to cover around 30 problem types, and if you master these 30 problem types you'll be able to answer 2 questions which are going to be asked from these chapters. And it's going to be a revision video, but we'll see application of each and every concept. So these are the problem types that we're going to discuss. Right, in center of mass, these are the problem types, and in rotation, in moment of inertia, around 2 to 3 problems will discuss. Problem types will discuss. In torque, there are 2 problem types. Rotation about the fixed axis, 1 or 2 problem types. Impulse momentum theorem, and then in pure rolling, around 2 problem types. Angular momentum, 2 to 3 problem types. So overall, around 30 problem types we're going to discuss. Now let us start with the very first problem type, and it is based on center of mass of a system of point masses. So let us see the question. So the identical spheres, each of mass 2m, are placed at the corners of a right angle triangle with mutual perpendicular sides equals to 4 meter each. Take point of intersection of these two sides as origin. The magnitude of the position vector of the center of mass of the system is 4 root 2 by x. So where the value of x is, right? So let me first draw the diagram here. So we have given right angle triangle, right? Let's say this is the right angle triangle, and these are equal sides. Equal sides are 4 meters long, and at each vertex we have a mass of 2m. So here we have a sphere of mass 2m. Since the radius of the sphere is not given, we can treat this sphere just like a point mass. So this will be 2m, and this is also 2m. So taking the point of intersection of these two sides as origin, so and the magnitude of the position vector of the center of mass. So I'm assuming they have taken this as the x-axis and this as the y-axis. So this will be 0, 0. This is the origin. Now how we can find the position vector of a center of mass? So the formula is, so position vector of center of mass will be given as summation of mi ri upon summation of mi, where ri is the position vector of ith particle, where mi is the mass of the ith particle, right? Or you can write this as m1 r1 plus m2 r2, so on and so forth, right? Divided by m1 plus m2, like this. If you want to find the x coordinate, then the x coordinate of the center of mass will be given as summation of mi xi, where xi is the ith component, is the x coordinate for the ith particle, divided by summation of mi. This is for x coordinate. Similarly, y coordinate of center of mass will be given as summation of mi yi, where yi is the y coordinate of the ith particle, summation of mi. Similarly, z coordinate can be given as summation of mi zi divided by summation of mi. So this you have to remember. Now let us apply this. So so for let me call this particle as 1, this particle as 2, this one is 3. So r1 will be nothing but 0, right? It is at the origin. And r2 will be 4 I cap, because the second particle is located at 4, 0. Similarly, the third particle is located at 0, 4. So r3 will be 4 j cap. Now let us apply this formula where we want to find the position vector of the center of mass. So RCOM will be 2m, that is mi, m1 times r1, which is 0, plus 2m r2, which is 4 I cap, plus 2m r3, which is 4 j cap, divided by sum of the masses. So 2m plus 2m plus 2m. So this comes out to be 2m times 4 I cap plus 4 j cap divided by 3 times 2m. So 2m will get cancelled out. So we are getting 4 by 3 I cap plus j cap. So its magnitude will be 4 by 3 times root 2. And this is given as 4 root 2 by x. So x comes out to be 3. So 3 is the answer of this question. Now let us see this question. Two bodies of mass 1 kg and 3 kg have position vector I cap plus 2j cap plus k cap and minus 3 I cap minus 2j cap plus k cap respectively. The magnitude of the position vector of the center of mass of this system will be similar to the magnitude of which vector? So R vector of center of mass will be given as 1 times I cap plus 2j cap plus k cap plus 3 times minus 3 I cap minus 2j cap plus k cap divided by sum of the masses, so 1 plus 3. So this will be 1 minus 9 I cap plus 2 minus 6 j cap plus 1 plus 3 k cap divided by 4. So this will be minus 8 I cap minus 4 j cap plus 4 k cap divided by 4, which is nothing but minus 2 I cap minus j cap plus k cap. Right, so if we look at the options, option A, its magnitude will be root of 4 plus 1 plus 1, that is root 6. So for this vector, the magnitude is root 6, right? So option A is the right answer. Whereas for other vectors, it is not root 6. So option A is the right answer. Right, so now let us see this question. Three identical spheres, each of mass m, are placed at the corner of a right angle triangle with the mutually perpendicular sides equals to 3 meter each. Taking point of intersection as of the mutually perpendicular side as origin, the magnitude of the position vector of the center of mass of the system. This question is similar, exactly, you can say that the values are changed. It is similar to the first question that we have discussed. So I'm keeping this as a homework. If you solve this, the value of x comes out to be 2, right? Right, so now let us see the next problem type where no shift in the center of mass of the 2-point mass system. So here we have given 2-point masses. We are going to shift the masses such that the center of mass is not shifting. So let us first read the question. So in a system of two particles of masses m1 3 kg, m2 2 kg are placed at a certain distance from each other. The particle of mass m1 is moved towards the center of mass of the system through a distance 2 centimeter. In order to keep the center of mass of the system at its original position, the particle of mass m2 should move towards the center by what distance? So here what you have to remember, if we have given 2-point masses or 3-point masses, but all masses must be collinear, right? So let us say there we have collinear masses which lies on the same line. So this is m1 and this is m2, right? And let us say this is the center of mass. And we have produced some displacements. Let us say d1 is the displacement in mass m1, d2 is the displacement in mass m2, and there is no displacement in the center of mass. It is at its original position. So here, if the center of mass is not shifting, then summation of mi di must be 0, right? So this condition we can apply, where di is the displacement of the ith particle. So here we have 1 and we have given the point particle of mass m1 is m1 is moved toward the center of mass. So let us say m1 is 3 kg. So 3 times by times 2 plus 2 times, let us say the displacement in the second mass is d2, and that will be 0. So it will be 6 plus 2 d2, and d2 comes out to be minus 3. The negative sign indicates that the mass 2 has to be displaced in the opposite direction. So, suppose we have displaced m1 in the right direction, m2 should be displaced in the left direction to keep the center of mass at its original position. So the answer will be 3 meters towards the center of mass. Now let us say this question. Two blocks of mass 10 kg and 30 kg are placed on the same straight line with coordinates 0, 0 and x, 0 in centimeters, and the block of 10 kg is moved on the same line through a distance 6 centimeter towards the other block. The distance through which the block 30 kg must be moved to keep the position of the center of mass unchanged. So let me first draw the diagram. So we have a 10 kg mass which is at the origin, and there is a mass 30 kg at x, 0. Right, and 10 kg mass is moved on the straight line through a distance 6 centimeter towards the other block. So the displacement is given. 6 centimeter. What should be the displacement of 30 kg to make sure that the center of mass doesn't shift? So here again I'm going to apply m1 d1 plus m2 d2 equals to 0. So m1 is 10, d1 is 6 centimeter plus m2 is 30, d2 we have to find. So it will be 60 by 30 with a negative sign. So d2 comes out to be minus 2 centimeter towards the other mass, right? So 2 centimeter towards the 10 kg. So option C is the right answer. Right, so now let us see how we can find the center of mass of extended body. So here we have given a uniform thin metal plate of mass 10 kg with dimension is shown. The ratio of x and y coordinates of the center of mass of the plate is n by 9. The value of n is, right, so there are multiple ways to solve such questions. So let me show you you can say the technique where we're going to consider principle of superposition. So if I make this a uniform sheet, right, so if I fill this cavity say with a mass plus m and minus m, right, so at the same location we have a positive mass and a negative mass, which is a hypothetical concept. So plus m minus m, they will cancel out each other, right? So what we can say, and if I split this entire sheet into 5 squares, right, so we have 5 squares plus 6, so we have 6 positive masses and 1 negative mass. So overall we have 6m and minus m. So if I consider 6m, the center of mass of that 6m will be at the geometrical center because it's made of a uniform material, right? So it will be at this particular position, right? So that is the center of mass of 6m. Whereas the center of mass of minus m will be at the center of mass of this square. So that will be minus m. Okay. Now what you have to do? You have to find the coordinates of 6m and minus m. So what is the what are the coordinates for 6m? It will be 1.5 comma 1, and the coordinates for minus m will be 1.5 comma 1.5. Okay, so now we're going to apply this concept where we have to find the position vector of the center of mass. So that will be 6m times its position vector, let me call this as r1, minus m and its position vector, let me call this as r2, divided by 6m minus m, right? So if you take so this m will be common, so it will be 6 r1. And what is r1 in this case? R1 for the first particle for 6m will be 1.5 I cap plus j cap, minus r2 will be 1.5 I cap plus 1.5 j cap divided by 5. So this will be 9 I cap plus 6 j cap minus 1.5 I cap plus minus 1.5 j cap divided by 5. So from this we'll be having 7.5 I cap plus 4.5 j cap divided by 5. So this will give us 1.5 and this will be 0.9, right? So we got the x and y coordinate and we have to find the ratio. So x coordinate of the center of mass is 1.5 centimeter. Okay, right, so units is not given, let us say 1.5 unit, and the y coordinate of center of mass will be 0.9 units. So the ratio will be 1.5 upon 0.9, which will be 5 by 3, and or I can write this as 15 by 9, and this is given as n by 9, so 15 by 9, so n is 15, right? I hope this technique is clear to you, right? So let us see the next question. On the same problem type, the distance of a center of mass from end A of a one-dimensional rod having mass density, linear mass density, is given as rho naught times 1 minus x square by L square, and the length is L, is 3L by alpha meter, where rho naught is constant. The value of alpha is, So we have to find the value of alpha, and the coordinates for the center of mass is given as, so it is located at 3L by alpha. Let me first draw the diagram. So we have given a rod. It has a variable linear mass density. So this end is A, this end is B. So this is our origin, x equals to 0, and this will be x equals to L. So here, what we're going to do in case of extended body, we're going to take a small element. So that is a small element, and it is located at a distance x, and the length of this element is dx, right? And in this case, the center of mass, x coordinate of center of mass, will be given as integral x dm, where dm is the particle which we are considering. This is our elemental mass dm, and its x coordinate will be x divided by integral dm. So that will be the x coordinate of the center mass if we have in a non-uniform linear mass density, right? So what we're going to do, what is dm in this case? So dm, linear mass density, is given. If you multiply linear mass density with the length of the element, you will get the mass of that element. So dm will be rho naught times 1 minus x square by L square times dx. So that is dm. So let us substitute. So it will be integral x rho naught 1 minus x square by L square times dx divided by integral rho naught 1 minus x square by L square times dx. Now rho naught is constant. It should be clearly mentioned in the question that rho naught is constant, right? So it should get cancelled out. Now if we integrate, and x is varying from 0 to L, so if we integrate this, so we'll get x square by 2 minus x raised to power, it will be 4 by 4 L square, and the limit will be from 0 to L. In the denominator, it will be x minus x cube by 3L square, and the limit is from 0 to L. Now let us substitute the limits. So we will get L square by 2 minus L raised to power 4 by 4L square divided by L minus L cube upon 3L square. So if you simplify this, it comes out to be L square by 4 divided by 2 by 3 L. So it will be L by 4 times 3 by 2. So which will be 3 by 8 times L. And this is given as 3L by alpha. So alpha is 8. So 8 is the answer of this question. Now let us say this question, where the position of the center of mass of a uniform semicircular wire of radius r placed in xy plane with its center at the origin and the line joining its ends as x-axis is given by 0 comma x r by pi. Okay, right. So let me tell you first, let me tell you the location of the center of mass, position of the center of mass for some symmetrical shapes. So in case of a semicircular ring, if there is a semicircular ring, center of mass will always be at the axis of symmetry. So in this case, this is the center of mass, and if this is origin 0 comma 0, where this is x-axis and this is y-axis, so the center of mass in this case will be 0 comma 2r by pi, where r is the radius. That is for a uniform semicircular ring. So this is for ring, semicircular ring. Now in case of a semicircular disc, again the center of mass will be about at somewhere on the axis of symmetry, and if this is x-axis and this is y-axis, this is the center of mass, and it is located at 0 comma 4r upon 3 pi, where r is the radius of this semicircular disc. Now if we have, say, a hemispherical shell, shell. In case of a hemispherical shell, the center of mass will be located at 0 comma r by 2. If this is origin, right, 0 comma 0. This is x-axis. And in case of a solid hemisphere, right? If we have a solid hemisphere, the center of mass will be located at 0, 3r by 8. And in case of a hollow cone, it will be located at 2h by 3, right? So if this is the y-axis and this is the x-axis, then the coordinate of the center of mass will be 0, 2h by 3 from the base. Now if this is for hollow. Now if we have a solid cone, in that case this distance will be h by 4, or you can say if this is origin and this is the x-axis, this is the y-axis, it will be 0, h by 4. Now these values you have to remember, so you don't have to do integration in exam, right? So you can avoid integration. So here we have given a semicircular wire of radius r and they are asking about the center of mass, so x is nothing but 2. Now look at this question. So the disk of mass m with uniform surface mass density sigma is shown in the figure. The center of mass of the quarter disk, the shaded area, is at a position xa upon 3 pi, xa upon 3 pi, where x is. So if I consider r as the radius and they're saying a is the area, let us see. So we know that in case of a semicircular disk, the center of mass is located at it will be on the axis of symmetry, and it will be at a distance 0. You can say the coordinates will be 0, 4r upon 3 pi, right? So if I consider this semicircular disk made up of two quarter disk, we can say the center of mass of the left quarter disk will be at the same level, right? But it will be along the axis of symmetry. Similarly, for the right quarter, it will be along the axis of symmetry at the same level. Only in that case, the center mass of these two quarter disks will be at 0, 4r by 3 pi, right? So it means this height should be 4r upon 3 pi. So sorry, this is pi, right? 4r upon 3 pi. So in case of a quarter disk, center of mass coordinates will be 4r upon 3 pi, 4r upon 3 pi. Now if you look at the question, they have given expression xa upon 3 pi, and where they are saying a is the area, so that is incorrect. A has to be the radius, right? So it should be radius of the quarter disk. Only in that case it will matches with our answer, right? So it will be 4r by 3 pi, 4r by 3 pi, and if you compare, x comes out to be 4. So 4 is the answer. So this is wrong, right? So it should not be the area, it should be the radius. Yes, so now let us see the next question. So here we have given a circular hole of radius a by 2 is cut out of a circular disk of radius a. So let me redraw the diagram, right? It is not as per proportion. So we have given a circular disk and we have cut out a hole of radius a by 2. So this radius is a by 2. This radius is a. Now this is our shape, right? So that is given to us. And we have to locate the center of mass. And by symmetry, we can say the center of mass will be along the axis of symmetry. That is the axis of symmetry, and it will be slightly to the left, right? Let me call this residual body mass as m1. And let us say it is located at a distance x from the center of the big circle, right? So if I fill this hole with a material which is having a mass m2, right? It will be of the same material, right? so which is having the same surface mass density, you can take. It will be located at the center, right? That will be m2. That is the center mass of this small circle. Now, the center of mass of m1 and m2 is nothing but the center of mass of the complete disk. So, which will be at the geometrical center. So, that will be the center of mass of m1 and m2. If I consider center of mass as the origin, right? If I consider C as the origin, then we can say m1x should be equals to m2 times a by 2, because this distance is a by 2. Right? So whenever we have this kind of a question, this type of a question, you should use principle of superposition, where you have to fill the cavity with the same material. So m1 can be, let us sigma is the surface mass density. So m1, so what is the area of this residual disk? It will be area of the big circle minus area of the small circle. So sigma times pi a square minus pi a by 2 square times x, and m2 is the mass of the small disk, so that will be sigma times pi a by 2 square times a by 2. Now sigma pi a square will get cancelled out, so we're left with 1 minus 1 by 4 times x, and this will be 1 by 4 times a by 2. So this will be 3 by 4 x equals to a by 4 times 2. So 4 will get cancelled out, so x comes out to be a by 6, right? So it will be located, so we have to find the centroid of the remaining circular portion with respect to the center O. So from O, so this we have calculated from this particular point, right? But the center of mass will be somewhere here, that is the center of mass. So this distance we have calculated, which is a by 6. So this distance will be a minus a by 6, which is 5a by 6. So option 3 is the right answer. Now let us see the next problem type, which is based on the acceleration of center of mass. So when we have given, say, multiple particles, they are moving with different accelerations, then acceleration of center of mass is given as summation mi ai upon summation mi, where ai is the acceleration of ith particle, mi is the mass of ith particle. So let us see this question. So two masses a and b, each of mass m, are fixed together by a massless spring. A force acts on mass B as shown in the figure. If the mass A starts moving away from B with an acceleration A, then the acceleration of the mass B. Right? So there is some correction in this question. If we are exerting force on B in the left direction, what will happen due to that force? The spring will elongate. And I'm assuming these two masses are lying on a frictionless surface. So the spring will elongate, and this spring will exert force on A in the left direction. So this force, spring force, will produce acceleration in A in the left direction. So they are saying it is moving away from B, which is itself is incorrect. So if I assume that they are saying the acceleration in A at like when we are exerting force F is A in the left direction, then if we apply the concept of center of mass, so the acceleration of center of mass will be the net force acting on the system divided by mass of the system, which is 2m. Now it is given as m mass of A times acceleration of A plus mass of B times acceleration of B divided by total mass of the system. Now this m will get 2m will get cancelled out, so F minus ma divided by m. So that should be the answer. So option 4 is the answer to this question if we are considering acceleration of A is in the left direction. But if we consider it is in the other direction, then the answer will change, right? So that you have to keep in mind. So sometimes like we have given some incorrect questions in exam. So this is one of those questions. A spherical body of mass 100 grams. Now this is the next problem type, which is based on impulse. And we know that impulse is the change in momentum that is being produced in the body. So that will be equals to change in linear momentum. If force time graph is given, then impulse can be written as F times dt from t1 to t2, where t1 to t2 is the duration in which the impulse is being exerted on the body. So here a spherical body of 100 grams is dropped from the height of 10 meters from the ground. After hitting the ground, the ball rebounds to the height 5 meter. the impulse of the force imparted by the ground to the body is given by. So we are dropping a ball from the height 10 meter, right? And after collision, it acquires a height of 5 meter. So what we can do in this such questions, first we have to find the velocity just before hitting the ground and just after the collision. So the velocity of the ball just before hitting the ground will be root of 2gh and h will be 10. So velocity just before hitting the ground will be root of 2, g is 9.8, h is 10. And the velocity just after hitting the ground will be again root 2gh, where h is the height attained by the ball, root of 2 g, h will be 5. So we got the velocities before collision and after collision, and the impulse will be p final minus p initial, right? So p final, so this can be written as m times v final minus v initial. That is the impulse. So mass is given as 100 grams, so 0.1 kilograms. And the final velocity is in the upward direction, initial velocity is in the downward direction. So if you consider upward direction as positive, upward as positive, then v final will be positive and v initial will be negative. So we can write v final as root of 10 times 9.8 minus root of 20 times 9.8, right? So that will be 0.1 and root 99.8 will come out, and then we have root 10 plus root 20, and we can also take root 2 out, so it will be 0.1 times root 98 times 1 plus root 2, and root 98 can be written as 7 root 2, so 1 root 2 plus 2. So it will be 0.7 times 2 plus 1.4, just for approximate calculation. So I'm taking root 2 as 1.4, so that will be 0.7 times 3.4. 21, 20. So if we simplify this, the answer comes out to be option 4. So it comes out to be 2.39 kilogram meter per second. So option 4 is the right answer. Now let us see the next question. In two different experiments, an object of mass 5 kg moving with a speed of 25 meters per second hits two different walls and comes to rest within 3 seconds and 5 seconds. Choose the correct option out of the following. So the final, you can say the momentum is 0 and the initial momentum is same. So the impulse will be same, right? So impulse is change in momentum. In both the cases, the body comes to rest, so the overall change in momentum is same. So impulse will be same, and they are also talking about the average force. So average force is defined as impulse upon duration. Since ball is getting stopped in 3 seconds, 5 seconds respectively, so the average force will be different. So impulse and average force acting on the object will be same for both the cases. Option A is incorrect. Impulse is same, but average force will be different. Impulse will be same for both cases, but the average force will be different. So option B is the right answer. Now let us see this question. Two billiards ball of equal mass 30 grams strikes a rigid wall with the same speed of 108 km per hour, but at different angles. So in the first case, it is hitting normally. In the second case, it is hitting obliquely. If the ball gets reflected with the same speed, then the ratio of the magnitude of the impulse imparted to the ball A and B by the ball along the x-axis. So we have to find the ratio of the impulse. So in the first case, if I consider left direction as positive, so the velocity after collision is u in the left direction. So we can say in the first case, the change in momentum or the impulse in A will be 2 mu, right? And in the second case, the impulse will be, so if I show the forces, this will be the final momentum, and this will be minus of initial momentum. So the resultant of P final and P initial minus of P initial will be the change in momentum. In the second case, we have two vectors and the angle between them is 90 degree. So what we can say, it will be, so impulse in the second case will be 2 times the momentum, which will be mu, times cos 45 degree. So this will be 2 times mu by root 2. So it will be root 2 times mu. So if you take the ratio, so it comes out to be 2 ratio root 2, or we can write this as root 2 ratio 1. So option 2 is the right answer. So this you can also remember, if a particle is hitting obliquely with at an angle theta, and it is an elastic collision where the speed doesn't change, then the change in momentum or the impulse will be 2 times mu cos theta. Right, so now let us see the next question. A bullet of 4 gram mass is fired from a gun of mass 4 kg. If the bullet moves with a muzzle speed of 50 meters per second, the impulse imparted to the gun and the velocity of recoil of the gun. So we have given a gun, and we are firing bullets. Gun has a mass 4 kilograms and it is firing bullet of 4 grams each. Now we have fired one bullet. So if I consider the bullet, the impulse which is being delivered to the bullet is mass of the bullet times the velocity acquired by the bullet. So impulse of bullet will be mass 4 by 1000 times the velocity of the bullet, which is 50. So this will give us 1 by 5 or 0.2 kilogram meter per second. So that is the impulse imparted to the bullet. Now in this case, if we consider gun and the bullet as the system, the linear momentum must be conserved in this case because there is no external force acting on the system. So impulse imparted to the gun. So impulse imparted to the gun will be same as 0.2 kilogram meter per second, because gun will also experience the same amount of change in momentum, but in the opposite direction. Now velocity of the recoil of the gun. So now we know the momentum of the gun, which is 0.2, and it is nothing but m times the velocity of the gun. Mass of the gun is 4 kgs, 0.2 by 4. So that will be the recoil velocity. So it will be 0.05. So option 2 is the right answer. Now let's see this question. A player caught a ball, cricket ball of mass 150 grams moving at a speed of 20 meters per second. If the catching process is completed in 0.1 second, the magnitude of the force exerted by the ball on the hand of the player. So here what you have to do, we have to find the average force. So average force will be the change in momentum produced divided by the duration. So change in momentum is mass times the velocity. Mass is 0.15, velocity is 20, and the duration is 0.1. So that comes out to be 3 by 2 times 20. So it will be 30 Newton. So option 4 is the right answer. Right, so let us see this question. A tennis ball is dropped on the floor from the height of 9.8 meter. It rebounds to the height of 5 meter. And ball comes in contact with the floor for 0.2 seconds. The average acceleration during the contact. So if we are able to find the average force, we can find the average acceleration. So average force is mass of the body times the average acceleration, right? So average acceleration will be average force upon mass. So let us find the average force. For average force, we need to find the change in momentum produced in the ball after collision, right, due to the collision. So we can say, let me draw the diagram first. This is the ground, and we are dropping a tennis ball from the height of 9.8 meter. And after collision, it rebounds to the height of 5 meter. So the velocity just before collision will be root of 2gh. That will be 2 times g is 9.8 times 9.8, right? And the velocity after collision, just after collision, will be root of 2gh, where h is the height attained by the ball after collision. 2 times, okay, g we have to take as 10, so that is given in the question. So g is 10. 10 times 5. So initial velocity will be, before collision, it will be root of 2 times 98, which can be written as 4 times 49, root of 4 times 49, which is 2 times 7. So 14 meters per second. And velocity after collision will be root of 100, which will be 10 meters per second. So final velocity is in the upward direction, initial velocity is in the downward direction. So if we consider upward as positive, so we can see the change in momentum or the impulse will be V final minus of V initial. So that will be 10 minus of minus 14. So that comes out to be 24 kilogram meter per second. So that is the change in momentum produced by the collision. So the average force will be delta P upon duration, which is given as 0.2. So 24 divided by 0.2. So this comes out to be 120 Newton. So we got the average force. So average acceleration will be average force divided by mass, and mass of the ball is given as, okay, so ball is not okay, average acceleration we have to calculate, and they are not given the mass. Okay, right. So I think they have assumed mass as 1 kg because they have given answer as 120 meters per second square. So acceleration will be 120 divided by 1. So 120 meters per second square, right? So they don't have given the mass. So and they have assumed 1 kg mass. Okay, so option, so it will be 120. Now let us see this question. Based on the average force, two billiard balls of mass 0.05 kg, each moving in the opposite direction, 10 meters per second, collide and rebounds with the same speed. If the time duration of the contact is 5 milliseconds, then what is the force exerted on the ball due to each other? So average force will be change in momentum divided by the duration. So what is the change in momentum? So there is a ball which is going in the right direction with 10. After collision, it rebounds with the same speed. So the change in momentum will be 2 times mu, and mass is 0.05, u is 10. So this comes out to be 1, sorry, it comes out to be, so it will be 0.5 to, yes, so it comes out to be 1 kilogram meter per second. So it will be 1 divided by duration, which is 0.005. So it will be 1000 by 5. So it will be 200 Newton. So option B is the right answer. Right. So let us see this question. A ball of mass 0.15 kg hits the wall with the initial speed of 12 meters per second and bounce back without changing its initial speed. If the force applied by the wall on the ball during the contact is 100 Newton, calculate the duration. So here we have to find, so we will, F average is given. We can find change in momentum, and delta T we have to calculate. So change in momentum will be 2 times mu. 2 and mass is 0.15, u is 12. So that will be, okay, take it as 0.3 times 12, or it will be 3.6 kilogram meter per second. So F average is 100. It is 3.6. So we can find delta T. So delta T comes out to be 36 millisecond, which is 0.036 seconds. So option B is the right answer. Right, now let us see the question based on momentum transfer. If the total energy transferred to the surface in time t is 6.48 into 10 raised to power 5, then the magnitude of the total momentum delivered to this surface for complete absorption. So in case of a complete absorption, you should remember that the force is defined as I A by C, where I is the intensity, which is energy per unit area, per unit time. Intensity is energy energy transferred per unit area per unit time. So here we have given energy. So energy per unit area per unit time is intensity, and E is given, right? So this is E. So we can write I as E by AT. So this can be written as, or E by T can be written as I times A. So it will be E by T by C. So that is the force. And we have to find the momentum transferred. And F can be written as change in momentum upon time. So T will get cancelled out. So the momentum transferred will be E by C, and energy is given as 6.48 into 10 raised to power 5 divided by 3 into 10 raised to power 8, which is the speed of light in vacuum. So this will give us 2.16 into 10 raised to power minus 3. So option 2 is the right answer. Right, so now let us see the next problem type, which is based on the relationship between the linear momentum and the kinetic energy. For particle A, B, C, D of masses m by 2, m, 2m, and 4m have the same momentum, respectively, the particle with maximum kinetic energy. So we know that kinetic energy is p square by 2m. So for a given momentum, kinetic energy is inversely proportional to mass. So the particle with the least mass will be having the greatest kinetic energy. So we can say the particle A will be having the greatest kinetic energy. So option 2 is the right answer. When kinetic energy of the body becomes 36 times of its initial value, original value, the percentage increase in the momentum of the body. So momentum is given as root of 2mk, where k is the kinetic energy. Mass is, we are not changing mass, we are just changing the kinetic energy. So momentum is directly proportional to square root of kinetic energy. When kinetic energy becomes 36 times, we can say the linear momentum will become root of 36 times. So root of 36 will be 6. So linear momentum will become 6 times. So we can say the percentage increase will be 6p minus p divided by p times 100. So it will be 500%. So option 4 is the right answer. Now, three bodies A, B, and C have equal kinetic energy, and their masses are given 400 grams, 1.2 kilograms, 1.6 kilograms. The ratio of their linear momenta. So we know that linear momentum is root of 2mk. So it is directly proportional to the square root of the product of mass and the kinetic energy, but they have same kinetic energy. So it will be directly proportional to square root of mass for given kinetic energy. So we can say the ratio will be root of 0.4 ratio root of 1.2 ratio root of 1.6, or we can write this as 1 ratio, if I divide throughout by root of 0.4, so that will be root 3, and this will be root 4, or this will be 1 ratio root 3 ratio 2. So option 2 is the right answer. Okay, now let's say this question. A body of mass 8 kg, another body of mass 2 kg are moving with equal kinetic energy. The ratio of their momenta. We have done similar question. I am keeping this as a homework. So option 2 is the answer for this question. Right, let us say the concept of momentum conservation. A simple pendulum of length 1 meter has a wooden bob of mass 1 kg. It is struck by a bullet of mass 10 raised per minus 2 kilogram, moving with a speed of 2 into 10 raised per 2 meters per second. The bullet gets embedded in the bob, and the height to which the bob rises before swinging back. So here we have given a wooden bob, which is having a mass of 1 kilogram, and it is connected with a string of length 1 meter. Now there is a bullet which is moving with a speed of 2 into 10 raised per 2 meters per second, and mass of the bullet is 10 raised per minus 2 kilogram, which is 0.01 kg, right? And we have to find the bullet gets embedded in the bob. So it gets embedded, it means after collision, bob and the bullet moves with the common velocity. So it will get embedded, and after collision, let us say the velocity of the system or the bob and the bullet is v. So first we have to conserve linear momentum just before collision and just after collision. So before collision, linear momentum will be nothing but the momentum of the bullet, which is 0.01 times the velocity. And after collision, it will be the bob as well as the bullet both moves with the same velocity. So it will be 1 plus 0.01 times v. So we can say v can be written as 2 by 1.01 meters per second. So we got the velocity. And now we have to find the height to which the bob rises before swinging back. So let us say the pendulum swings like this, and this is the extreme position where the velocity becomes 0. So now what we can do, we can apply energy conservation. So there will be a loss in, you can say, kinetic energy and the gain in gravitational potential energy, and this height is h. So mgh, where m is the sum of the mass of the bullet and the bob, will be equals to half mv square. So m will get cancelled out, and h we have to calculate. So h will be v square by 2g, and v is, so it will be 2 square upon 1.01 square v square, and 1 upon 2, 20. And if you look at the options, like options are quite far apart, right? So we can say this will be 4 and this will be 5, right? So we'll be having 0.2 upon 0.01 square, or this can be written as 0.2 times right. So sorry, it is 1, not 0.01. Right, so this is nearly equals to 0.2 meters. So option 2 is the right answer, because 1.01 square will be nearly equals to 1. So now let us see the next problem based on momentum conservation. The average force of 125 Newton is applied on a machine gun firing bullets, each of mass 10 grams at a speed of 250 meters per second to keep it in position. So the number of bullets fired per second. So it means whatever will be the change in the momentum of all the balls, the same change should happen in case of the gun. But since and if we want to hold the gun, then we have to exert force in the opposite direction, right? So first, in such questions, you have to find the total momentum of the bullets. How many bullets we have? Let us say we are firing n bullets per second. So we can say n times momentum of one bullet. So that will be 10 divided by 1000 times 250, right? So that many bullets are fired per second, and this is the total change in momentum of the bullet. So this is nothing but the force exerted, average force exerted by the gun on the bullet. The same force will be exerted by the bullets on the gun, right? So it will be 4 and this will be 2.5 times n. So that is average force. Now we have to find the number of bullets, and we have given 125. So this is 125. So n comes out to be 125 by 2.5, right? So this comes out to be 50. So option 2 is the right answer. Now let us see the next question. A man of 60 kg is running on the road and suddenly jumps into a stationary trolley car of mass 120. So there is a stationary trolley car which is having a mass of 120 kilograms. And there is a person, and this person which is having a mass of 60 kilograms, it jumps over this trolley car. The trolley starts moving with a velocity 2 meters per second. The velocity of the running man was, so let us say it is moving with a velocity u, and when it jumps on the trolley car, I'm assuming both the car as well as the person, they starts moving with a velocity 2 meters per second in the forward direction. So here we can conserve linear momentum between the person, like before jump and the after jump. So before jump, we can say the linear momentum of the system will be 60 times u, and after collision or after After jump, it will become 120 plus 60. That is the total mass of the system times the velocity of the system. So it will be 60 u equals to 180 v, and v is given as 2 meters per second. So this will give us 3. So it comes out to be 6 meters per second. So here I have assumed that there is no friction anywhere when right. So that I have assumed. Let us see this question. A body of mass capital M at rest explodes into 3 pieces in the ratio 1:1:2. Two smaller pieces flies off perpendicular to each other with velocity 30 and 40 and the velocity of the third piece. So here we have given, say, a body of mass M. So let us say, so this will become what? So it will be small m, let us, this is small m, this is 2m. So 4 small m will be equals to capital M. So small m comes out to be m by 4. So, so the two smaller pieces will be having mass m by 4. So this is m by 4, this mass is m by 4, and this will be 2, it will be m by 2. Okay. The smaller pieces are moving perpendicular to each other. So let us say it is going in this direction, this piece is going in this direction. And let us say it has a momentum p1, it has a momentum p2. Right. And before explosion, the body was at rest, so initial momentum will be 0. So let us say the third piece moves in this particular direction, so that is p3. So p1 plus p2 plus p3, so the momentum should be 0. So we can say p3 will be minus of p1 plus p2. So the magnitude of p3 will be same as the magnitude of the resultant of p1 and p2. Now what is the magnitude of p1? Its mass is m by 4 and its velocity is given as, say, 30, right? Similarly, p2, its mass is m by 4 and its velocity is given as 40. So we got p1 and p2 and they are perpendicular to each other. So the resultant of p1 and p2 will be p1 square plus p2 square. So which is nothing but m by 4 root of 30 square plus 40 square. So this comes out to be m by 4, and this can be written as 10 will come out root of 9 plus 16. So it will be 50 m by 4, which is 20 m by 2. So the momentum, so the resultant of p1 and p2 vector will be 25 m by 2, and that will be equals to mass of the third particle, which is m by 2 times velocity. Let us say v is the velocity. So from this, v comes out to be 25 meters per second. So option B is the right answer. Now let us say this question. A bag of sand of mass 9.8 kg is suspended by a rope. A bullet of mass 200 grams traveling with a speed of 10 meters per second gets embedded in it. Then the loss of kinetic energy will be. Right. So the similar question we have done. So there is a bag which is having a mass of 9.8 kilograms, and there is a bullet which is moving with a speed of 10 meters per second, and its mass is given as 0.2 kilograms. And after collision, this bullet gets embedded in the sandbag, and let us say the velocity acquired by this combined system is v after the collision. So first we can conserve linear momentum in the horizontal direction. So that will be 0.2 times 10, that is the initial linear momentum, is equals to 9.8 plus 0.2, that is total mass of that system times v. So it will be 2 divided by 10. So v comes out to be 0.2. Now we have to find what is the loss in kinetic energy during this collision. So loss will be initial kinetic energy of the system minus final kinetic energy of the system. So initial kinetic energy will be half m v square. So that is the initially before collision, the kinetic energy is nothing but the kinetic energy of the bullet, minus half mass of the system is 10, v is 0.2, square of that. So let us simplify this. So this comes out to be 10 minus half times 10 times 0.2 times 0.2. So this will be 0.2. So that will be 9.8 joules. So option B is the right answer. Now let us see another question based on momentum conservation. A large block of wood of mass 5.99 kilogram is hanging from two massless cords. A bullet of mass 10 grams is fired into the bullet in the block and gets embedded in it. The block and the bullet then swings upward. Then the center of mass rises a vertical distance of 9.8 centimeter before the bullet pendulum comes momentarily to rest at the end of its arc. The speed of the bullet just before collision. Right, so what is happening in this case? After collision, this bullet gets embedded in this block. So first we have to conserve linear momentum. So it will be mv, that is the initial momentum before collision, and after collision it will be capital M plus small m. Let us say the velocity becomes v prime just after collision. So v prime will be mv upon capital M plus small m, and small m is given as 10 grams. So we can write this as 0.01 kilogram, and capital M is given as 5.99. So that will be 5.99 plus 0.01. So that will be 0.01 divided by 6, or v by 600. So we got the velocity just after collision. Now we can apply energy conservation. So the center of mass has gone up by h. So the loss in kinetic energy will be gain in gravitational potential energy. So half m plus capital M times v prime square will be equals to m plus small m times g times h. So mass will get cancelled out. V prime square will be v square upon 600 square times half, and g is 9.8 and h is given as 9.8 centimeter. So that will be 9.8 by 100. Now let us take the square root on both sides. So it can be written as 9.8 square divided by 10 square times 600 square, and then we have 2 root of this, that will be v. So it will be 9.8 divided by 10 times 600 root 2, right? So if I simplify this, so it comes out to be 0.98 times 600 times root 2. So it comes out to be 831.6. So 831.6. So the closest answer is option number 3. So that is the answer of this question. Now let us see this question. A ball of mass 200 grams rests on a vertical post of height 20 meter. A bullet of mass 10 grams traveling in the horizontal direction hits the center of the ball. So here we have given a vertical post and there is a ball of mass 0.2 kilograms, and the height is given as 20 meters, and there is a bullet of mass 10 grams, so 0.01 kilograms, and it is moving with a velocity, so that is not given, right? Let us, this velocity is u. After collision, both travels independently. The ball hits the ground at a distance 30 meters and the bullet at a distance of 120 meter from the foot of the post. So after collision, let us say the velocity of the ball is v1 or v2, and the velocity of the bullet is v1, right, after collision. And the ball hits the ground at a distance of 30 meters. So this the ball hits the ground at 30 meter, whereas the bullet hits the ground at a distance of 120 meter. So that is given, right? So after collision, we have like projectile from the height. So what we can say, range in case of a projectile, horizontal projection of a particle from a height is u times root of 2h by g, where h is the height from which we are throwing the particle and u is the velocity. So here 30 will be v2 times root of 2h. H in this case will be 20 and g is 10. So it comes out to be 2 times v2. So v2 will be 15 meters per second. And similarly, for the bullet, after collision, we can say range is 120. So V1 times root of 2h by g, 2 times 20 by 10. So that will be 2 times V1. So V1 comes out to be 60 meters per second. So we got the velocities just after collision for the bullet as well as for the ball. Now we can apply momentum conservation. So 0.01 times u, that is the before collision momentum. After that, it will be zero point 0.2 times v2, which is 15, plus 0.01 times v1, which is 60. So from this, we can remove this. So it will become 20. This will get cancelled out. So it will be 300 plus 60. So it should be 360 meters per second. So option 4 is the right answer. Right, so let us see this question. A bullet of mass 0.1 kilogram moving horizontally with a speed of 400 meters per second hits a wooden block of mass 3.9 kilogram kept on the horizontal rough surface. So there is a block resting on a rough surface, 3.9 kilograms. Bullet is having a mass of 0.1 kilogram and it is moving with 400 meters per second. The bullet gets embedded in the block and moves 20 meters before coming to rest. The coefficient of friction between the block and the surface. So first, let us find the velocity acquired by the system just after collision. So it will be, let us do a momentum conservation. So 0.1 so 0.1 times v will be equals to 3.9 plus 0.1 times, let us say v is the velocity just after collision. So here the frictional force will be non-impulsive because normal reaction is non-impulsive. So that's why we can conserve linear momentum in the horizontal direction. So it will be 40 and that will be 4. So v comes out to be 10 meters per second. Now we got the velocity, right? So and we have to find the coefficient of friction and we have given displacement after that. So we can say work done by the frictional force will be equals to change in kinetic energy of the system. So work done by the frictional force will be equals to minus mu mg times the displacement which is given, and change in kinetic energy will be final minus initial, which is half m total mass of the system times v square, and v is 10. So m will get cancelled out. So it will be minus mu, g is 10, displacement is 20, minus 1 by 2 times 100. So this will give us 5, this will give us 2. So mu comes out to be 1 by 4, which is 0.25. So option 4 is the right answer. Right, so let us see this question. An object of mass m1 collides with another object of mass m2, which is at rest. After the collision, the objects move with equal speeds in the opposite direction. The ratio of masses m2 and m1. So again, we have to conserve linear momentum. So we have given two bodies. So this is m1, it is moving, say, with a velocity u, and there is another body which is at rest. It is having a mass m2. So after collision, they move in the opposite direction with equal speed. Let us say that speed is v. So let us do momentum conservation before and after. So this will be m1u will be equals to m1 minus v plus m2 v. So v comes out to be m1u upon m2 minus m1. Right, so since momentum is a vector quantity, if the body is going in the left direction, I'm taking it as negative. So we got v as m1 u upon m2 minus m1. Now we have to find the ratio of masses, and is there anything else given in the question? Equal speed in the opposite direction, the ratio of the masses. So ratio we have to calculate. So I think what else you can do? Since no information is given, let us assume that the collision is elastic. If nothing is given, you can assume elastic collision. If collision is elastic, velocity of separation will be equals to velocity of approach. So in this case, the velocity of separation will be 2v and the velocity of approach is u. So we can say u will be 2 times v. So it will be v equals to m1 2 times v divided by m2 minus m1. So we will get cancelled out. So m2 minus m1 is equals to m1 times 2, or 3m1 is equals to m2. So m1 by m2 or m2 by m1. So m2 by m1 will be 3:1. So they have not given that the collision is elastic. So we have to assume, right? If no, if not, no, suppose we require one more equation, then you can assume elastic collision. Right, so let us say this question. A ball of mass 10 kg moving with a velocity of 10 root 3 meters per second along the x-axis hits another ball of mass 20 kg which is at rest. After the collision, first ball comes to rest while the second ball disintegrates into two equal pieces. Right, so it splits up into 10 kg and 10 kg. One piece starts moving along the y direction with a speed of 10 meters per second, and the second piece starts moving at an angle of 30 degree with respect to the x-axis. The velocity of the ball moving at 30 degree with the x-axis is x meters per second. The configuration of the piece after collision is shown in the figure. The value of x to the nearest integer. So here there was a right. So the first ball comes to rest. So that is the first ball which is going in the positive x direction, and its velocity is 10 root 3. Mass is 10 kilograms. And after collision, it comes to rest. And the second body splits up into two parts. So first part, which is having mass 10 kg, goes in the upward direction. The other piece, which is having mass 10 kg, goes in this particular direction, making an angle of 30 degree with the x-axis. So here, what we can do, we can conserve linear momentum, right? So because there is no external force acting on the system. So now we can conserve linear momentum in the x direction as well as in the y direction. So if we consider x direction, we can say 10 times 10 root 3, that is the initial momentum in the x direction, is equals to 10 times v2 cos 30, right? That is the momentum component of the second piece in the x direction. And in the y direction, we can say 10 times 10 minus 10 times v2 sine 30 degree should be 0, because in the initial momentum in the y direction is 0. So this 10 will get cancelled out, this 10 will get cancelled out. So from this we can say v2 will be 10 root 3 divided by cos 30, which is root 3 by 2. So it will be 20. And we have to find v2 only, right? So which comes out to be 20. So 20 is the answer. Now let us see this question. A ball of mass 10 kg moving with a velocity of 10 root 3 meters per second along the x direction hits another ball of mass 20 kg which is at rest. After collision, the first ball comes to rest and the second one disintegrates into two pieces. Right, so it is same question. So I'm keeping this question as a homework, right? Instead of finding the velocity of the second piece, here we have to find the angle theta, right? So if we solve this, it comes out to be 30 degrees, right? Right, let us say this question. A ball with a speed of 9 meters per second collides with another identical ball at rest. After the collision, the direction of each ball makes an angle of 30 degree with the original direction. The ratio of velocity of the balls after collision is x ratio y. We have to find the value of x. So let me draw the diagram. So this is a ball which is having a mass m. It is moving with a velocity of 9 meters per second. And here we have given a ball which is at rest. Identical ball, na? Which is at rest. So it collides, and let us say after collision, and it will be oblique collision, right? And after collision, it moves in this particular direction, whereas this ball moves in this particular direction. And both makes an angle of 30 degree with the original direction. So this angle will be 30, this angle will be 30. Let us say this is V1 and this is V2. Ratio of velocity we have to calculate. So again, we can conserve linear momentum. So what we can say, initial momentum in the horizontal direction will be m times 9 is equals to m times v2 cos 30 plus m times v1 cos 30. So from this m will get cancelled out. So we got cos 30 is root 3 by 2. So that will be 9 times 2 by root 3 is v1 plus v2. So we can write this. Let us rationalize the denominator. So we got 6 root 3 as v1 plus v2. Now, in a vertical direction, we can again conserve linear momentum. Initially, before collision, there is no linear momentum in the vertical direction. So the final linear momentum in vertical direction should be 0. So it will be m v2 sine 30 minus m v1 sine 30 should be 0. So from this m will get cancelled out. So we can say v2 should be equals to v1. So it should be 1:1, right? So x will be 1. Got it? So that should be the answer. What percentage of kinetic energy of a moving particle is transferred to the stationary particle when it strikes the stationary particle 5 times its mass? So there is a stationary particle which is 5 times the mass of the particle. And the collision is head-on elastic. So in case of elastic collision, we can conserve linear momentum. We can also conserve kinetic energy before and after collision. So here it is moving, let us say, with the velocity u. And after collision, let us say after collision, the particle has a velocity v1 in the right direction, and the particle and the body with 5m mass is having velocity v2 in the right direction. So first we can conserve linear momentum. So m times u is equals to m times v1 plus 5m times v2. So from this m can be eliminated. So v1 plus 5 times v2 will be u. So that is the first equation. And in case of a elastic collision, head-on elastic collision, velocity of separation will be equals to velocity of approach. So in this case, velocity of separation will be v2 minus v1 and velocity of approach is u. Right, so we got two equations and there are two unknowns. So what we're going to do, let us add these two equations. So when we add, v1 will get eliminated. So we'll get 6 times v2 is equals to 2 times u. So v2 comes out to be u by 3. And v1 will be v2 minus u, that will be u by 3 minus u, so that will be minus 2u by 3. So we got the velocities after collision. Now we have to find the loss in percentage of kinetic energy of the moving particle is transferred to the stationary particle. So stationary particle kinetic energy, so K2 will be half m v square and v2 square, and that will be u square by 9. And the initial kinetic energy of the first particle is half m u square. So how much of this energy has gone into the second particle, that what we have to calculate, right? Percentage of this. So we need to find K2 as a percentage of K1. So we can say K2 by K1 times 100. So K2, so that will be 5 by 18 mu square divided by 1 by 2 mu square times 100. So mu square will get cancelled out. And this 2 will give us 9 here. So that will be 500 by 9. So which comes out to be 55.5. So option C is the right answer. So now let us see this question. A body having a specific charge, so 8 microcoulomb per gram, is resting on a frictionless plane at a distance 10 centimeter from the wall. It starts moving towards the wall with when a uniform electric field of 100 volt per meter is applied horizontally towards the wall. If the collision of the body with the wall is perfectly elastic, then the time period of oscillation. Now here, we have to find the time period of oscillation, and this distance is given. So this distance is 10 centimeter. Right? So the force exerted by the electric field will be in the right direction. So this is E. So the force is also in the same direction. Force will be Q times E. So we have a force, constant force acting as long as if this body is not in contact with the wall. And when it undergoes a collision with the wall, in case of an elastic collision, the speed doesn't change, right? Because the wall is quite heavy, the speed doesn't change. So let us first find the time taken by the body to cover a displacement of 10 centimeter. So let me call this position as A and this point as B. So time to cover this distance 10 centimeter will be, let us apply equation of motion. So acceleration will be QE by M. Q is 8 microcoulomb. E is given as 100. Mass is 8 micro. So Q by M is given. So that will be 8 into 10 raised to power minus 6 coulomb per gram, and gram is 10 raised to power minus 3. So it comes out to be 0.8 meters per second square. So we got the acceleration. So time from A to B will, so let us find this time. So we can use S is equals to ut plus half at square. Initial velocity is 0 and S is given as 10 centimeter, that will be 0.1. Half acceleration is 0.8. So time from A to B we can find from here, right? So this decimal will go, this will give us 4. So it will be 1 by root of 1 by 4, that will be time from A to B, which comes out to be 0.5 seconds. So that is the time from A to B, and the motion is quite symmetrical, right? Because after collision, the force doesn't change, right? Force will remain same as like acceleration will remain same as 0.8 meters per second in the right direction. So we can say time from B to A is again 0.5 seconds. So the time period, so the motion will repeat itself after a time interval of 1 second. So 0.5 plus 0.5. So that will be 1 second. So that is the time period of oscillation. 1 second is the answer. Now let us see this question, which is again based on elastic collision. As per the given figure, a small ball P slides down the quadrant of a circle and hits the other ball Q of equal mass. So let us say its mass is M, Q also has a mass M, which is at rest. Q is at rest. Neglecting the effect of friction and assume the collision to be elastic, the velocity of ball Q after collision. So you have to remember, when we have a head-on elastic collision between two particles with same mass, they will exchange their velocity. So let us find the velocity of P just before hitting Q. So we can apply energy conservation. So so particle P is coming down by a distance 20 centimeters. So we can apply loss in gravitational potential energy, gain in kinetic energy. So we can say mgh, which will be 0.2 meters, will be equals to half mv square. That is the velocity of P just before hitting Q. So m will get cancelled out and g is 10. So that will be 4. V square will be 4. So v will be 2 meters per second. Now we have, after collision, P and Q will exchange their velocity. P will come to rest. Q starts moving with the velocity 2 meters per second in the right direction. And we have to find the velocity of Q after the collision. So answer will be option 3. Okay, right. So a body of mass 1 kg collides head-on elastically with another body of mass 3 kg. After collision, the smaller body reverses its direction of motion and moves with a speed of 2 meters per second. The initial speed of the smaller body before collision is, so we have given a smaller body of mass 1 kg. Let us, its velocity is u in the right direction, and it hits a stationary body which is having a mass 3 kg. It is at rest, and after collision, the smaller body moves in the opposite direction with a speed of 2 meters per second. And this 3 kg body, let us say its velocity becomes v. Now what we can do, we can conserve linear momentum before and after collision. So before it will be 1 times u, and after collision it will be 1 times minus 2 plus 3 times v. And it's a elastic collision. And in now we got a relation between u and v. So u minus, or we can say 3v minus u is equals to 2. So that is the first equation. And in elastic collision, velocity of separation will be equals to velocity of approach. So velocity of separation in this case will be v plus 2 and velocity of approach will be u. Now we got another relation, u minus v is equals to 2. So this is first equation, this is second equation, and we want to find the value of u. So if we add these two equations, u will get eliminated. So 4v, so 2v will be equals to 4. So v comes out to be 2 and u will be 2 plus v. So it comes out to be 4 meters per second. So the answer will be 4. Right, so now let us see the next illustration. A body of mass 2 kg moving with a speed of 4 meters per second. So there is a body of mass 2 kg moving with a velocity of 4 meters per second, makes an elastic collision with another body at rest. So there is another body and its mass is not given. Let us assume its mass is m and it is at rest. And it has an elastic collision with this body and continues to move in the original direction but with 1/4 of its initial speed. So after collision, the first body keeps on moving with 1/4 of its initial velocity, so it will become 1 meters per second, right? And the other body which is having a mass m, let us say its velocity becomes v after collision. The speed of the two bodies center of mass. So we have to find the velocity of the center of mass of the system. Right, so first what we can do, we can conserve linear momentum. So it will be 2 times 4 equals 2. That is the momentum before collision, and after collision will be 2 times 1 times plus m times v. So this will be 8 minus 2. So that will be mv, which is, so mv comes out to be 6. Right? So we got mv, and now we know that in elastic collision, velocity of separation will be equals to velocity of approach. So in this case, velocity of separation is v minus 1 and velocity of approach is 4. So v comes out to be 5. So m comes out to be 6 by 5. So which is 1.2. So we got the mass of the second particle or second body, and velocity of center of mass will be m1 v1 plus m2 v2 divided by m1 plus m2. So m1 is 2 and the velocity is 1 plus m2 is, okay, right. So velocity of center of mass, either you can use before collision condition or after condition, after collision, you will get the same answer. So if I consider velocities after collision, it will be 2 times 1 plus 1.2 times v2, and v2 in this case will be 5 divided by 2 plus 1.2. So this will be 2 plus 6 divided by 3.2, which is 8 by 3.2. So it comes out to be 1 upon 0.4, which will be 5 by 2. And if I multiply numerator and denominator with 5, we will get 25 by 10, which is given as x by 10. So x comes out to be 25, right? So 25 is the answer. Right, so let us see this question. Given below are two statements. One is labeled as assertion, other is labeled as reason. Let us see the assertion. Body P having mass m moving with speed u has a head-on collision elastically with another body q having a mass m initially at rest. If m is very small in comparison to capital M, body q will have a maximum speed equals to 2u after collision. Okay, right. So let me show you the situation. So there is a body which is having a mass m, and there is another body which is at rest, and it is moving with a velocity u. And small m is very small in comparison to m, and it is saying, so this is a body P and this is body Q. There will be no change in the velocity of heavier body, right? Or if it changes, it will be marginal, right? So we can assume that the mass of velocity of the first body will not change after collision because small m is very small in comparison to capital M. But what happens to the other body? So that will be, so velocity of Q will be given as 2 times the initial velocity of the heavier body, which will be u minus velocity, initial velocity before collision velocity of the lighter body. So it will be 0. So this comes out to be 2u. So yes, so the second body will move with two times u. So state assertion 1 is correct. Now let us see the reason. During elastic collision, the momentum and the kinetic energy are both conserved. Yes, this is true. And by using the momentum conservation and the kinetic energy conservation, we'll be able to find the velocities of the body after collision. And by using this approximation, where m is very small in comparison to capital M, we'll be able to get this result. So reason is the correct explanation for the assertion. So option 3 should be the right answer. Right. So let us say this question based on elastic collision. Three objects A, B, and C are kept in a straight line on a frictionless horizontal surface. The masses of A, B, and C are m, 2m, and 2m. So that is given. A moves towards B with a speed of 9 meters per second and makes an elastic collision with it. So and then B makes an inelastic collision with C, and all the motions occur at the same straight line, the final speed of C. So B is at rest, C is at rest initially. So A is going in the right direction with a velocity of 9 meters per second. So first let us apply elastic collision concept between A and B. So after collision, so let us conserve linear momentum. So this is A, B, it is moving with 9 meters per second. And after collision, let us say A has a velocity v1 and B is having a velocity v2. So let us conserve linear momentum. So it will be m times 9 is equals to m times v1 plus 2m times v2. So this will give us 9 equals to v1 plus 2v2. So that is our first equation. Now in case of elastic collision, velocity of separation will be equals to velocity of approach. So velocity of approach in this case will be 9 and the velocity of separation will be v2 minus v1. Now if we add these two equations, we will get v2. So v2 comes out to be 18 by 3, which is 6 meters per second, and v1 comes out to be v2 minus 9, which is 6 minus 9, which is minus 3. So after collision, A starts moving in the backward direction with a speed of 3 meters per second. So we got the velocity of A and B after collision, and thereafter B makes a completely inelastic collision with C. So when we have a completely inelastic collision, both the bodies will move with the same velocity after collision. So if we consider B and C, so B is going in the right direction with 6 meters per second, and here we have C, which is at rest. So after collision, both will have same velocity, let us say v prime. So let us apply momentum conservation. So it will be 2m times 6 will be equals to 4m times v prime. So v prime comes out to be 12 by 4. That will be 3 meters per second. Now we got the velocity of C after collision, and we have to find the final speed of C, which will be 3 meters per second. Right, so let us see this question. A particle of mass m moving with velocity v collides with a stationary particle of mass 2m. After collision, they stick together and continue to move together with velocity. So, right, so direct application of momentum conservation. So there is a body of mass m, its velocity is v, and there is a stationary particle of mass 2m. So that is the initial momentum. And after collision, they sticks together, right? So they starts moving with a common velocity. Let us that velocity is v prime. So it will be m plus 2m times v prime. So v prime comes out to be v by 3. So option 3 is the right answer. Now let us see this question. A rubber ball is released from the height 5 meters above the floor. It bounces back repeatedly, always rising to 81 by 100 or 100 of the height through which it falls. Find the average speed of the ball. So what is so average speed is nothing but the total distance upon total time taken, right? So we are dropping a ball, let us say from a height of 5 meter. So after first collision, it rises to 81 by 100 of its of 5 meter. So if I take this as h, so it rises up to 0.81 of h, right? And after that, and this 0.81 can be written as, so this 81 by 100 can be written as 9 by 10 square, right? So what we can do, let us find the coefficient of restitution in this case. So before collision and after collision, so height attained is zero point 0.9 square times h. So we know that h will be e square times the original height h naught. So here h is 0.9 square times h, that will be e square times h naught. So and this will be, so this will be h. So h will get cancelled out. So coefficient of restitution in this case will be 0.9. So we got coefficient of restitution. And in this case, if you want to find the total distance covered by the ball before it comes to rest, so let us find that total distance and then we'll find the total time. So let me just tell you the result. So the total time taken will be root of 2h by g 1 plus e upon 1 minus e, and total distance covered will be h times 1 plus e square upon 1 minus e square, right? And so the average speed will be the ratio of these two. So s by t. So s will be 5 times 1 plus e square. So e square is 0.81. 1 minus 0.81 divided by root of 2h. So 2 times 5 by 10. 1 plus e. So e will be 0.9 upon 1 minus 0.9. So let us simplify this. So this will be 5 divided by root of 1 times 1.81 divided by 0.19 times 0.1 divided by 1.9. Right, so if I simplify this, so we have 1.81 divided by 0.19 divided by 1.9 times 5. So this comes out to be 2.5. So option 4 is the right answer. It is not exact answer, it will be close to 2.5, right? So I'm getting 2.507. So it should be option number 4. So these two formulas you have to remember. The ball will, the total distance, total time taken by the ball before it comes to rest will be given by this, where E is the coefficient of restitution, and the total distance covered will be given by this. Right. Right. So now let us see the next illustration. So a body starts falling freely from the height h, hits an inclined plane in its path at a height small h. As a result of this perfectly elastic collision, the direction of the velocity of the ball becomes horizontal, and the value of h by small h for which the body will take the maximum time to reach the ground is, right? So let me just draw the diagram. So let us, this is the inclined plane and this is the ground level, and we are releasing a ball from the height h. So initial velocity is 0, it is being released. So this height is capital H from the ground, and it hits at a point which is at a height small h from the ground, and we have to find the value of h by small h such that the time taken by the body to reach the ground will be maximum. So after collision, velocity will become horizontal like this, right? So let me mark some important points. Let us, this point is A, this point is B, and this point is C. So the time from A to B will be root of 2h minus small h by g, right? Where h minus small h is AB. And time from B to C will be root of 2h by g. So the total time from A to C will be root of 2 by g times root of h minus small h plus root of h. Now we want to maximize this time. So what we're going to use, we can use maxima minima. So let us differentiate the time with respect to small h. This will be root of 2h. The integration, the differentiation of root of h by 2 will be 1 upon 2 root h minus small h times minus 1. And the differentiation of root h will be 1 upon 2 root h. Now to maximize the time, the rate should be 0. So dt by dh should be 0. So from this we can say 1 by root h minus small h will be equals to 1 by root h. Now if we square, if we cross multiply this and square it, we'll get h minus small h will be equals to h. So h by 2 will be equals to small h, and we have to find the value of h by small h, which is nothing but 2. Right, so the answer will be 2. Right, so now let us see the concept of variable mass system. So in case of a variable mass system, the thrust is given as dm by dt times the relative velocity. Right, so this concept we have to use in this question. Sand is being dropped from a stationary dropper at a rate of 0.5 kilograms per second on a conveyor belt moving with a velocity of 5 meters per second. The power needed to keep the belt moving with the same velocity will be. So let us see. So this is a conveyor belt. And it is moving with a constant velocity of 5 meters per second. And we are adding sand particles on this conveyor belt with a rate of 0.5 kilograms per second. So with respect to this conveyor belt, the velocity of the sand particle in the horizontal direction will be 5 meters per second in the left direction. So we can say V relative will be 5 meters per second. So the thrust, so the sand particle will exert thrust in the left direction. So that thrust will be 5 times the rate at which the mass is getting added. So that will be 0.5 kilograms per second. So this comes out to be 2.5. Now that is the thrust which is acting in the backward direction. So we have to exert equal and opposite force in the forward direction to keep on moving this conveyor belt with the same velocity. Right. So that so we can say the power that we need to supply will be 2.5 times the velocity, and velocity is 5 meters per second. So this comes out to be 12.5 watt. So option D is the right answer. So we are done with center of mass and linear momentum and collision part. Now let us discuss rotational mechanics. So the very first topic is moment of inertia. So let us see the question. So we have given assertion: an electric fan continues to rotate for some time after the current is switched off. Right, so after the current is switched off, it has some inertia. Due to that inertia, its angular velocity will slowly decay, right? It becomes 0 after some time. So that is because of the inertia. So the reason R is fan continues to rotate due to inertia of motion, right? So reason is the correct justification for the assertion. So it should be option 2, right? Now let's see this question, moment of inertia of a point masses. So in case of a point masses, moment of inertia is given as mr square. So 4 point masses, each of mass 1 kg, are placed at the 4 corner of a square of side 2 meter. Moment of inertia of the system about an axis perpendicular to its plane and passing through one of its vertex is. So let us say this is the axis. About this axis, we want to find the moment of inertia, and there are 4 particles, 1 kg each, placed at each vertex. The perpendicular distance of this mass, let me call this as mass 1, this is mass 2, 3 and 4. Mass 1, the distance of mass 1 from the axis will be 0, and the perpendicular distance of mass 2 from the axis will be 2 meter, whereas the distance of mass 3 from the axis will be 2 root 2 and meters, and the distance of mass 4 from the axis will be 2 meter. So we have to simply add up the moment of inertia, contribution towards moment of inertia by all the particles. So for mass 1 it will be 0. For second mass it will be 1 times 2 square. For the third mass it will be 1 times 2 root 2 square. And for the fourth mass it will be 1 times 2 square. So 4 plus 8 plus 4, so that will be 16 kilogram meter square. So 16 is the answer of this question. Three balls of masses 2 kg, 4 kg, and 6 kg respectively are arranged at the center of the edges of an equilateral triangle of side 2 meter. So we have given an equilateral triangle of side 2 meter, and there are three masses 2 kg, 4 kg, and 6 kg placed at the centers of the edges. Moment of inertia of the system about an axis through the centroid. So the three masses placed at the center, let us say this is 2 kilograms, 4 kilograms, 6 kilograms, and we want to find the moment of inertia about the axis which is passing through the centroid, and it is perpendicular to the plane of this triangle. So for that we need to find the perpendicular distance of these masses from the axis. Side is 2. So the distance of the centroid from the side is a by 2 root 3, where a is the side. So that will be 2 by 2 root 3. So it comes out to be 1 by root 3. So 2 kg, 4 kg, and 6 kg are all equidistant from the axis. So we can say it will be 2 times 1 by root 3 square plus 4 times 1 by root 3 square plus 6 times 1 by root 3 square. So that will be 2 plus 4 plus 6 times 1 by root 3 square. So that comes out to be 12 times 1 by 3, which will be 4 kilogram meter square. So 4 is the answer of this question. Now let us this question. 4 point masses, equal masses m each, are placed at the corner of a square of length L. The moment of inertia of the system about an axis passing through A and parallel to dB. So A and parallel to dB. So about this particular axis, we have to find the moment of inertia. So let us find the perpendicular distance of all these 4 point masses from this axis. So so for this mass is 1, so its distance, its contribution will be 0 because it lies on the axis, and the perpendicular distance of second mass will be L by root 2, that is half of the diagonal L by root 2. Similarly, the perpendicular distance of mass 4 from the axis will be L by root 2. And for the third mass, this distance will be root 2 times L, right? So this distance is root 2 times L. Now we have to simply add up the moment of contributions, right, towards the moment of inertia. So it will be 0 by the first mass. By the second mass, it will be m times L by root 2 square. By the third mass, it will be m times root 2 L square. And by the fourth mass, it will be m times L by root 2 square. So it will be m L square by 2 plus 2 ml square plus ml square by 2. So which comes out to be 3 ml square. 3 ml square, so option 3 is the right answer. Right, so now let us see the moment of inertia of an extended body. So ratio of the radius of gyration of a hollow sphere to that of a solid cylinder of equal mass for a moment of inertia about their diameter x is AB, as shown is root of 8 by x, the value of x. So here we have given two extended bodies. This one is a solid cylinder, sorry, hollow sphere. So this one is hollow sphere, and this one is a solid cylinder. And we have to find the ratio of the radius of gyration. Now radius of gyration is k. So mk square will be equals to moment of inertia about that axis. So k is radius of gyration. So basically we have to find root of I by m, where I is the moment of inertia. So you should know what is the moment of inertia of a hollow sphere about the axis passing, which is coinciding with the diameter. So in case of hollow sphere, it will be 2 by 3 mr square, where mr square. So that is the moment of inertia about this axis. In case of a cylinder, if the axis is perpendicular to the axis of the cylinder and it is passing through one of the end, in this case the moment of inertia will be m, where L is the length, ml square by 3 plus mr square by 4. So this you have to remember. If this axis is passing through the center, in that case it will become ml square by 12 plus mr square by 4, right? Where r is the radius, where l is the length. So if I substitute the value, l is 4r, so that will be m times 4r square divided by 3 plus m by 4 times r square. So this will be 16 by 3 plus 1 by 4 mr square, which comes out to be 64 plus 3 by 12, and it will be 67 by 12 mr square, right? So we got the moment of inertia of the cylinder. We know what is the moment of inertia of the hollow sphere, and we have to find the ratio of the radius of gyration. So in case of in case of the shell or sphere, let us say the radius of gyration is k. So we can say k1. So we can say m k1 square will be 2 by 3 mr square. And here m k2 square will be 67 by 12 mr square. Now if you take the ratio of 1 and 2, it will be k1 square by k2 square will be 2 by 3 by 67 by 12, which is nothing but 2 by 3 times 12 by 67. So this will give us 4, so which will be 8 by 67. So k1 by k2 will be root of 8 by 67. And this is given as root of 8 by x. So from this, x comes out to be 67. So 67 is the answer of this question. Now let us say this question. The moment of inertia of a semicircular ring about an axis passing through the center and perpendicular to the plane of the ring is 1 by x mr square, where r is the radius, m is the mass of the semicircular ring. The value of x will be. So here we have given a semicircular ring which is having a mass m, radius is r, and we have to find the moment of inertia about this axis, which is normal to the plane and passing through the center. So in this case, it comes out to be mr square, right? So that is the moment of inertia. And this is nothing but mr square by x. So x comes out to be 1. Even if we have a complete ring of mass m, then the moment of inertia will remain same. That will be mr square. Or if I have a, say, an arc of mass m, which subtends an angle theta at the center, again, in this case, the moment of inertia will be mr square. So that you have to remember. Consider a uniform wire of mass m and length L. It is bent into a semicircle. Its moment of inertia about a line perpendicular to the plane of the wire and passing through the center. So it is saying we have a wire which is having a mass m and length is L. Now what we have done, we have made a semicircular ring by using this wire. So it means the radius, so pi r, half of the circumference will be equals to L, so the radius will be L upon pi. Mass will not change, right? Mass will be m only. And we have to find the moment of inertia about this axis. So we know that moment of inertia will be mr square. So m r square will be L square upon pi square. So option 3 is the right answer. Now that is this question. A uniform solid cylinder of radius r, length L, has a moment of inertia I1 about an axis of the cylinder. A concentric solid cylinder of radius r by 2 and length L by 2 is canned out of the original cylinder. If I2 is the moment of inertia of the carved out portion of the cylinder, then I1 by I2 will be, right? So in this case, we have given, let us say this is the first, this is the cylinder of radius r. And length L. So its moment of inertia about this axis will be mr square by 2. It is same as the moment of inertia of a disk. But what, okay, right, so mass is m. And it's a uniform cylinder. So this mass can be written as density times the volume, and volume will be pi r square times L. So I can write this as rho pi r raised to power 4 L by 2. So that is the moment of inertia. Now what we have done, a concentric solid cylinder of radius r by 2 and length l by 2 is canned out of the original cylinder, and I2 is the moment of inertia of that the carved out portion. So now we have a cylinder which is having a radius r by 2, length is l by 2. So its mass will be density times the volume, that will be pi r square by 4 times the length, which will be rho pi r square l by 8. So its moment of inertia will be mass, the radius square divided by 2. Right, so this comes out to be rho pi r raised to power 4 L divided by 8 into 8, so 64, and we have to find the ratio. So this is I2 and this is I1, so we have to find I1 by I2. So that will be 1 by 2 divided by 1 by 8 times 8, so 64 by 2, so that will be 32. So 32 is the answer of this question. Okay, right. So now this question is based on radius of gyration. A solid sphere and a solid cylinder of same mass and radius are rolling on a horizontal surface without slipping. The ratio of their radius of gyration. So for solid sphere, the moment of inertia about the axis passing through the center is 2 by 5 mr square, whereas for solid cylinder it is mr square by 2, and this is nothing but mk1 square, and this will be mk2 square. So m will get cancelled out. Now if you take the ratio, so we can say k1 square by k2 square will be 2 by 5 upon 1 by 2, which will be 2 by 5 times 2, 4 by 5. Now if you take the ratio of that, so k1 by k2, it will be 2 by root 5, and this is given as 2 by root x. So x is nothing but 5, right? So 5 is the answer of this question. The radius of gyration of a cylindrical rod about an axis of rotation perpendicular to its length and passing through the center will be. It's saying we have a cylindrical rod and its length is given, right? So length of the rod is 10 root 3. Since radius is not given, so we can assume it's a thin rod. So it is just like a thin rod, and we have to find the moment of inertia about an axis perpendicular to its length and passing through the center of mass. And it is nothing but ml square by 12. And this will be mk square, so m will get cancelled out. So k will be L by root 12, and length is given as 10 root 3. So 10 by root 4, so that will be 5. So radius gyration will be 5 meters. Now let us say this question: two identical spheres, each of mass 2 kg and radius 50 centimeter, are fixed at the ends of a light rod. Rod is light, so we don't have to worry about the moment of inertia of the rod. So that the separation between the center is 150 centimeter. Then the moment of inertia of the system about an axis perpendicular to the rod and passing through its midpoint is x by 20 kilogram meter square, where the value of x is. Now here, this question is based on the theorems, parallel axis theorem. So let me first tell you what is parallel axis theorem. Suppose there is a rigid body. This is the center of mass, and we know the moment of inertia about an axis passing through the center of mass. Let us, that is IC. And we want to find the moment of inertia about this axis, which is parallel to the given axis, which is passing through the center. If this distance is d, then the moment of inertia about this axis will be IC plus mass of the body times square of the distance between the axes. Right, so I'm going to use this concept. So I'm going to find the moment of inertia of both the spheres about the given axis, about which we want to find the moment of inertia, right? So let me draw the diagram for this question. So we have given two spheres, and they are joined with a light rod. Radius is given, so radius is 50 centimeter. Mass 2 kilograms. So the contribution towards moment of inertia by one of the sphere will be About this, so I'm going to apply parallel axis theorem. So about this axis, it will be 2 by 5 mr square, and then this is the distance d, which is nothing but L by 2, where L is the length of the rod, or you can say L is the distance between the center of the spheres, right? So that is L by 2. So it will be, so contribution towards moment of inertia by one sphere will be 2 by 5 mr square plus m times L by 2 square. Now if you multiply this with 2, we'll get the moment of inertia for this rigid body. So it will be 2 times 2 by 5. Mass is given as 2 kilogram. Radius is 0.5 centimeters. So that will be 0.25. And mass is 2. Length, distance is given as 150 centimeter. So it will be half of that. So 75. So 0.75 times 0.75. So let us simplify this. So this will give us 0.05. So this can be written as 3 by 4. This can be written as 3 by 4. And this can be written as 5 by 100. So it will be 20, 10, 5. So 2 times 1 by 5 plus 9 by 8. So let us take the LCM. So 8 plus 45 divided by 40 times 2. So this comes out to be 20. So it will be 53 by 20. And that is given as x by 20. So x is 53, right? So now let us see the next question. Two identical solid sphere, each of mass 2 kg and radii 10 centimeter, are fixed at the end of a light rod. The separation between the centers of the sphere is 40 centimeter. The moment of inertia of the system about an axis perpendicular to the rod passing through its middle point. Same question. I'm keeping this question as a homework. And if you solve this, you will get 176 as the answer. Now let us see this question. Moment of inertia of four bodies having same mass m and radius 2r are as follows. So I1 is moment of inertia of a solid sphere about its diameter. So that will be, for solid sphere it is 2 by 5 mr square. So it will be 2 m, and r is 2r, right? So 2r square. So this will be 8 mr square by 5. I2 is moment of inertia of a solid cylinder about its axis. So for solid cylinder it is mr square by 2. It will be m 2r square by 2. So that will be 4, or you can say 2 times mr square. So moment of inertia I3 is moment of inertia of a solid circular disc about its diameter. So here, if we have a circular disc and we want to find the moment of inertia about its diameter, so here we're going to use perpendicular axis theorem. About the axis of symmetry, moment of inertia is mr square by 2. And if I consider any two mutually perpendicular diameters, right? So these are perpendicular. Both these diameter are, you can say, identical. Mass is distributed uniformly or identically with respect to these two axes. So let us say this is I and this is I. And by the perpendicular axis theorem, I plus I will be equals to mr square by 2. So I comes out to be mr square by 4. So here it will be mr square by 4. R is 2r. So it comes out to be mr square. I4 is the moment of inertia of a thin circular ring about its diameter. Again, we can use perpendicular axis theorem. It comes out to be mr square by 2. So it will be m 2r square by 2. So that will be 2 mr square. And we have given, if 2 times I2 plus I3 plus I4 is x, then what is the value? X times I1, then what is the value of x? So let us substitute the value in this equation. 2 times I2, which will be 2 mr square. I3 is mr square plus I4, which is 2 mr square, is equals to x times I1, and I1 is 8 by 5 mr square. So mr square will get cancelled out everywhere. So that will be 2 times 3 plus 2, x times 8 by 5. So 6 plus 2 will be 8. 8 times 5 by 8. So that is x. So x comes out to be 5. So 5 is the answer of this question. Right, so now let us see the next problem. So here we have given two lists and we have to match the columns, right? So list 1A is given as moment of inertia of a solid sphere of radius r about any tangent. So in case of a solid sphere, and if you want to find the moment of inertia about the axis which is tangent to the sphere, we have to use parallel axis theorem. So it will be, so about this axis it will be 2 by 5 mr square plus, and about this axis it will be 2 by 5 mr square plus mr square. So that will be 7 by 5 mr square. So A corresponds to 2, right? So A corresponds to 2. So if you look at the option, so we can eliminate option B and option D. Now let us see B. Moment of inertia of a hollow sphere of radius r about a tangent. So in case of a hollow sphere, moment of inertia about the axis passing through the center is 2 by 3 mr square. So we want to find the moment of inertia about the axis which is tangent. So that will be 2 by 3 mr square plus mr square. So that will be 5 by 3. So B corresponds to 1, right? So if you look at the option, so option C is the right answer. Now let us see this question. The moment of inertia of a uniform thin rod about a perpendicular axis passing through one end is I1. The same rod is bent in the ring and its moment of inertia about a diameter is I2, and the ratio of I1 and I2 is x pi square by 3, then the value of x will be. Okay, right. So let me just show you the situation. So we have given a rod. That is, its mass is m and length is L. So its moment of inertia about an axis which is passing through its end and perpendicular to the rod is ml square by 3. We know this, right? Now what we have done, we have made a ring with this rod. So the circumference will be L, that will be 2 pi r. So r will be L upon 2 pi. And the moment of inertia of this ring about its diameter, we know that now here we can use perpendicular axis theorem. So about the diameter, it will be mr square by 2. So it will be m L square upon 4 pi square by 2. And the ratio is given as x pi square by 3. So ml square by 3 divided by ml square by 8 pi square. This is given as x pi square by 3. So ml square will get cancelled out. So we can write this as 8 pi square by 3, which is x pi square by 3. So x is 8. So 8 is the answer of this question. Now let us see this question. 4 identical discs, each of mass m, diameter a, so radius will be a by 2, are arranged in a small plane as shown in the figure. If the moment of inertia of the system about an axis OO prime is x by 4 ma square, then the value of x will be. So if you look at this diagram, so there are 4 discs which lie in the same plane, and as per the figure, it looks like OO prime is coinciding with the diameter of disc 1 and disc 2. So for disc 1 and disc 2, contribution towards moment of inertia is quite easy. So we know the moment of inertia of a disc about the diameter is mr square by 4. So the contribution of 1 and 2 will be m a by 2 square by 4 times 2, right? So that is the contribution by 1 and 2. Now for 3 and 4, we have to apply parallel axis theorem. So first we can find the moment of inertia about the diameter, and then we can apply parallel axis theorem to find the moment of inertia, their contribution towards the moment of inertia. So it will be m a by 2 square by 4 plus m a by 2 square, because this distance is a by 2. So times 2. So we have to add these two terms. So let us add them. So m a square will be common. So then we'll be having 1 by 16 times 2 plus 2 times 1 by 16 plus 2 times 1 by 4. So this will give us 8. This will give us 8. 2. So if you take the LCM, so 8 will be the LCM. So 1 plus 1 plus 4. ma square. So ma square times 6 by 8, which is 3 by 4 ma square. So x will be 3. So that is the answer. Now let us see this question. ICM is the moment of inertia of a circular disk about an axis CM. So CM is passing through the center, right? And passing through its center and it is perpendicular to the plane of the disk. So if this is the disk, this is the axis they are talking about, which is passing through the center. And the moment of inertia about this is ICM. IAB is its moment of inertia about an axis AB perpendicular to the plane and parallel to the axis CM at a distance 2 by 3r from the center. Now this is the another axis which is at a distance of 2 by 3r, and about this it is IAB where r is the radius of the disk. The ratio of IAB and ICM is x by 9, the value of x. Very easy. So we know the moment of inertia about axis passing through the center of mass for a disk will be mr square by 2. And for IAB we can apply parallel axis theorem. So ICM plus m times 2 by 3 r square. So this will be mr square by 2 plus 4 by 9 mr square. So 1 by 2 plus 4 by 9 times mr square. So that will be 9 plus 8 by 18 mr square. So that will be 17 by 18 mr square. Now the ratio of IAB and ICM is x by 9. So 17 by 18 mr square divided by mr square by 2. So that is given as x by 9. So which is 17 by 9. So x will be 17. So 17 is the answer. Right. So now let's see this question. If a solid sphere of mass 5 kg and a disk of mass 4 kg have the same radius, then the ratio of moment of inertia of the disk about the tangent in its plane to the moment of inertia of the sphere about its tangent. So we have given a disk. The moment of inertia about this axis, let me call this as I1. And for a solid sphere, the moment of inertia about its tangent, this is sphere, solid sphere, let us call this as I2. And its ratio is given as x by 7. So I1 will be what? So for to finding the moment of inertia about this axis which lie in the plane of the disk, first we need to find the moment of inertia about the axis passing through the center and coinciding with the diameter. And we know that it is mr square by 4, right? By perpendicular axis theorem we can find this. So I1 will be mr square by 4 plus mr square, which is nothing but 5 by 4 mr square. Mass of the disk is given as 4 kilograms. Radius is r only, so that will be 5r square. Now for a sphere, it will be, again we can apply parallel axis theorem. So it will about the axis passing to the center is 2 by 5 mr square. So I2 will be 2 by 5 mr square plus mr square, because r is the distance between the two axes. So it will be 7 by 5 mr square and m is 5. So that will be 7r square. So the ratio, so I1 by I2 will be 5 by 7, which is given as x by 7. So x will be 5. Right. So let us see this question. So assertion is given. Moment of inertia of a circular disk of mass m and radius r about x and y axis passing through its plane, and z axis which is perpendicular to its plane were found to be ix, iy and iz. The radii, respective radii of gyration also about all the three axes will be same. So that is incorrect. So I'm assuming that x and y axis they are considering perpendicular, right? So that is incorrect. It is not same. If they are perpendicular, then ix plus iy will be equals to iz, right? So the moment of inertias are different. So similarly, the radius of gyrations can be different. Ix and iy will be equal if they are like perpendicular, right? And iz will be different. Reason: a rigid body making rotational motion has fixed mass and shape. In light of the above statement, choose the most appropriate answer for the option given below. So if you look at the reason, rigid body, right? So here we have given a circular disc. Making rotational motion has a fixed mass and shape. Yeah, that is correct. A rigid body has a fixed mass and shape. So assertion is not correct, but the reason is correct, right? So this statement R is correct, right? So option 2 is the right answer. Now let's see this question. Four identical solid spheres, each of mass m and radius a, are placed with their centers on the four corners of a square of side B. The moment of inertia of the system about one side of the square where the axis of rotation is parallel to the plane of the square. So here we have given a square of side B, and there are four identical spheres placed at its vertices. Radius of the sphere is given as a and mass is given as m, right? And we have to find moment of inertia about an axis which is coinciding with one of the side of the square. So in this case, if I consider sphere 1 and 2, this axis is passing through their center. So we can say the contribution of 1 and 2 towards moment of inertia will be 2 by 5 m b square times 2, right? Now the contribution of 3 and 4, for that we have to apply parallel axis theorem. So about their axis passing through the center, it will be 2 by 5 mr square, 2 by 5 mb square. Sorry, not mb square, radius is given as a, right? So this is ma square, not mb square. And for 3, moment of inertia of contribution of 3 towards the moment of inertia for this system will be 2 by 5 mb square, ma square plus mb square. So I have applied parallel axis theorem and multiply this with 2 because we got the same, we have the same contribution by 4. So we have to add these two terms. So it will be m, so this is m, yes, so this will be, m will be common, and this will be 4 by 5 a square plus 4 by 5 a square plus 2b square. So we can write this as 8 by 5 a square plus 2b square or times m, which is 8 by 5 ma square plus 2 mb square. So 8 by 5 ma square plus 2. So option 3 is the right answer. So let us see this question. So here we have given two lists. So in list A, list 1, we have given different configurations of rigid bodies, and in list 2 we have given the moment of inertia. So let us say A. So moment of inertia, of a rod length L, mass m, about an axis perpendicular to the rod passing through its midpoint, we know that it is ml square by 12. So A corresponds to 3. Look at the option. So we can say option 1 and option 2 are incorrect, so we can eliminate them. Now let us check for C, right? Moment of inertia of a rod of length 2L, mass m, about an axis perpendicular to the rod passing through its midpoint. So there is a rod of mass m and length 2L, so it will be m 2L square by 12, which will be ml square by 3. So it comes out to be 2, right? So C corresponds to 2. So it means option 3 is the right answer. Right, so let us see this question. The figure shows two solid discs with radius capital R and small r respectively. If mass per unit area is same for both, what is the ratio of moment of inertia of a bigger disc around axis AB, which is perpendicular to the plane of the disc and passing through the center, of moment of inertia of a smaller disc around one of its diameter lying on its plane, given m is the mass of the larger disk. So we have two disks, they have the same surface mass density, that is mass per unit area, and capital M is given as the mass of a bigger disk, and bigger disk has a radius capital R. So surface mass density, let us say it is sigma, it will be mass of the bigger disk divided by its area. So area is pi r square. So if we want to find, so we can say capital M is sigma pi r square, Now if you want to find the mass of small disk, that will be sigma times the area of a small disk, that is pi r square. So it will be m divided by pi capital R square times pi small r square. So that will be capital M r square upon capital R square. Now the moment of inertia. So we have to find the ratio of the moment of inertia of the big disk, and we have to find the moment of inertia for big disk about the axis which is perpendicular to the plane of the disk and passing through the center. Let me call that I1. So I1 will be m capital R square by 2. Now for the smaller disk, we have to find moment of inertia about one of its diameter. So that will be mass of the smaller disk times its radius by 4. Right, here I have used perpendicular axis theorem. So mass of a smaller disk is m r square by capital R square times r square by 4. So we have to take the ratio. So it will be mr square by 2 ratio mr raised to power 4 by 4r square. So this will give us 2, m will get cancelled out. So we will get 2 r raised to power 4 ratio small r raised to power 4. So option 4 is the right answer. Now let us see this question. Moment of inertia of a disk of mass m and radius r about any of its diameter is mr square by 4. The moment of inertia of this disk about an axis normal to the disk and passing through a point on its edge will be. So they are saying about this axis we have to calculate, right? And this axis is perpendicular to the plane of the disk and passing through the edge. And we have given moment of inertia about the diameter. So we know that moment of inertia about the axis of symmetry is mr square by 2, and this distance is r. So about this axis it will be mr square by 2 plus mr square. So that will be 3 by 2 mr square, which is given as x by 2 mr square. So x will be 3. So 3 is the answer. Right, let us this question. Solid sphere A is rotating about an axis PQ. If the radius of the sphere is 5 centimeter, then its radius of gyration about PQ will be root x. The value of x is, so it is rotating about this axis PQ, right? So what we're going to first we'll find the moment of inertia about the axis passing through the center, and then we can apply parallel axis theorem. So about this axis it will be 2 by 5 mr square, and this distance is say d. So that will be 2 by 5 mr square plus m d square. Here r is given as 5 centimeter and d is given as 10 centimeter. So let us substitute the values. So it will be 2 by 5, m will be common, 5 square plus d will be 10. So 10 square, and that is given as m k square, right? Where m k square is where k is the radius of gyration. So if you eliminate m, then we'll get k in centimeters because we have taken r and d in centimeters. So this will become 10 plus 100, which is equals to k square. So k will be root of 110. So x will be 110, right? So that is the answer. So let us see this question. So I think this is repeated. We have just discussed this question, right? Answer is 3, right? Okay, uniform thin bar of mass 6 kg and length 2.4 meter is bent to form an equilateral hexagon. The moment of inertia about an axis passing through the center of mass and perpendicular to the plane of the hexagon is dash times 10 raised to power minus 1 kilogram meter square. So here what we have given, there is a uniform bar which is having a mass 6 kilogram and its length is 2.4 meters. Now with this bar we have formed a hexagon, right? So hexagon is being formed, and we want to find the moment of inertia about an axis which is normal to the plane of this hexagon and passing through the center of mass, right? So what we have to do in this case, we can split, we can just think of one of the side, and we'll find the contribution towards moment of inertia by one of this side, and we can multiply that with 6, we'll get the answer, right? So what we're going to do, I'm going to use parallel axis theorem. First, we're going to find the moment of inertia about an axis which is normal to this plane and passing through the center of one of the side. Now, if you consider one of the side, its mass will be 1 kilogram because total mass is 6, and its length will be 2.4 by 6, which is 0.4. Length is 0.4 meter. So about this axis, the moment of inertia will be m L square by 12. So m L square by 12. Now the distance between these two axes will be, it will be root 3 by 2 times the side length. So it will, this distance d will be root 3 by 2 times which is 0.4 side length. So it will be 0.2 times root 3. So about this axis, it will be 1 into 1 times 0.4 square by 12 plus mass is 1 kilogram times 0.2 root 3 square. This is the contribution by one of the side. You can multiply this with 6. We will get the contribution by all the sides. So let us simplify this. So it will be 6 times 16 into 10 raised to power minus 2 divided by 12 plus 4 into 10 raised to power minus 2 times 3. So let us take it inside. So that will be 2 8. So it comes out to be 8 plus 72. So for 12 times 6, 72 times 10 raised to power minus 2. So it comes out to be 80 into 10 raised to power minus 2, or 8 into 10 raised to power minus 1. And so the answer will be 8, right? So this should be 8. Now let's see the next question. So here we have to find the moment of inertia of 4 bodies having same mass and radius. Let us say m is the mass, radius is r, are reported as. So I1 is the moment of inertia of a thin circular ring about its diameter. So for a circular ring about the diameter, it will be mr square by 2. And I2 is the moment of inertia of a circular disk about an axis perpendicular to the disk and going through the center. So in case of a disk, it will be mr square by 2. And moment of inertia of a solid cylinder about its axis, it is again mr square by 2. Moment of inertia of a solid sphere about its diameter, so that will be 2 by 5 mr square. So we can say this will be 0.5 mr square. This is again 0.5 mr square. This is 0.5 mr square, and it will be 0.4 mr square. So let us see the first option. I1 plus I2 is less than I2 plus I4. I1 plus I2 is 1 mr square and I2 plus I4 is 0.9 mr square. So this is incorrect. I1 plus I2 is I3 plus 5 by 2 I4. So I1 plus I2 is mr square and I3 is 0.5 mr square, and 5 by 2 will be 2.5 and I4 is 0.4. So let us see. I3 is 0.5 mr square, 5 by 2, so that will be 5 by 2 times 0.4 mr square. So this will be 0.2, that will be 1, so 1.5. That is incorrect, right? So this is 1.5 mr square. So this is incorrect. I1 plus I2 plus I1 is equals to I2 and I2 is equals to I3. So that is correct, but and it is greater than I4. Yes, so option 3 is the right answer. Option 4 says I1 is equals to I2 is equals to I3 and it is less than I4, which is incorrect. So option 3 is the right answer. Right, so now let us see the next concept, which is based on the torque calculation. A force is minus p k cap acts on the origin of a coordinate system. The torque about the point 2, 2, minus 3 is p times a I cap plus b j cap. The ratio of a to b is x by 2, the value of x. So what we have given, there is an at the origin, a force is being exerted, which is in minus, let me show this. So this is x-axis, y-axis, and this one is z-axis. The force is in the negative z direction. So that is the force which is minus p k cap. And we have to find the torque about a point 2, 3. So there is a point 2, minus 3. So this is the point, let us say 2, minus 3. So about this we want to find the torque, and we know that torque is r cross f. So that will be the r vector. So r vector is nothing but 0 minus 2 I cap plus 0 minus of minus 3 j cap, right? So which will be minus 2 I cap plus 3 j cap. So we got r vector, force is given to us. So let us find the torque about point, say, A. So torque about A will be r cross f minus 2 I cap plus 3 j cap cross with the force which is minus p k cap. So we can just take this minus p out. So minus p and I cross k will be minus j. So that will be plus 2 j cap, and j cross k will be I cap. So that will be plus 3 I cap. Right, so so if we want to find the ratio of A and B, so A will be minus 2 and B will be minus 3 if we compare. So 2 by 3 will be A by B, and this is given as x by 2. A by B. A by B will be, sorry, I made a mistake here. This will be A. So A will be minus 3 and B will be minus 2. So A by B will be 3 by 2, which is given as x by 2. So x comes out to be 3. So 3 is the answer. Right. So again, based on the same concept, if force F, which is 3 I cap plus 4 j cap minus 2 k cap, acts on a particle having position vector 2 I cap plus j cap plus 2 k cap, then the torque about the origin. So about the origin, position vector is 2 I cap plus j cap plus 2 k cap, and force vector is 3 I cap plus 4 j cap plus minus 2 k cap. So let us find r cross f. We can also find the cross product using the determinant approach. Let me use the determinant approach in this question. So we have I, j, k. I is the coefficient of I, j and k 2, 1, 2, and this will be 3, 4, minus 2. So it will be I 1 times minus 2 minus of 3 times 2, 3 times 2. No, sorry. 4 times 2, sorry. Minus of 4 times 2. Minus of j cap times, it will be 2 cross 2 times minus 2 minus of 3 times 2 plus k cap, that will be 2 times 4 minus of 3 times 1. So if we simplify this, it will be minus 2 minus 8. So minus 10 I cap, and that will be minus 4 minus 6 plus 10 j cap, and this will be 8 minus 3, so plus 5 k cap. So option 2 is the right answer. So torque force is given, and we have to about the origin is tau. So torque of this force about the origin is tau. If the force acts on a particle whose position vector is 2 I cap plus 2 j cap plus 2 k plus k cap, then the value of tau. It is based on the same concept where r vector, this is r vector and this is f vector, right? You just have to take the cross product. So if you solve this, the answer option C will be the right answer. Right, so let us say this question based on the same concept. A triangular plate is shown, a force F, which is 4 I cap minus 3 j cap, is applied at point P. So at P we are exerting a force. The torque at a point P with respect to O and Q. Right, so with respect to O, let us find the torque with respect to O. So with respect to O, the position vector of the point of application of the force will be OP vector. Let me call this as R1. So R1 vector can be written as position vector of P minus position vector of origin. So position vector of P will be what? So we can say the coordinates for P will be tan cos 60 degree and tan sin 60 degree, right? So we can write this as 5 centimeter comma 5 root 3 centimeter. And we have to find torque. I think we have to find the torque in SI units. Let us find this in SI units. And no information is given about like whether the force is in newtons or it is in dynes. I think, okay, let us consider this to be in dyne, right? And so this will be, so let us find the torque in CGS only. So RP will be 5 I cap plus 5 root 3 J cap. So the torque about O will be R1 cross F vector, and R1 is 5 I cap plus 5 root 3 J cap cross with 4 I cap minus 3 J cap. So this can be written as minus 15 I cross J will be K cap, and then minus 20 root 3 K cap. So this comes out to be minus 15 minus 20, minus 15 minus 20 root 3 K cap. Okay, right. So they have given this force in dyne only, right? So if you look at the options, no need to calculate the torque about Q because we already got the answer by finding the torque about O. So option 1 is the right answer. So this will be in dyne centimeter. Right, let us see the next question. A force F, which is 4 I cap plus 3 J cap plus 4 K cap, is applied on an intersection point of x equals to 2 plane with the x-axis and the x-axis. Okay, let me first draw that. Let us say this is the x-axis and this is y-axis and this is z-axis. So if I draw a plane x equals to 2, so let us say this is 2 comma 0 comma 0. So this is the plane. So we have to find this force is applied on an intersection of the point x equals to 2 plane and the x-axis. So at this particular point we are exerting force, means we are exerting force at 2 comma 0 comma 0. The magnitude of the torque of this force about a point 2 comma 3 comma 4. So let us say there is a point 2 comma 3 comma 4. About this we have to find the torque. So we have to draw position vector of the point of application of the force. So that is the position vector R. Okay, so and let us say the position vector of this point A is RA, and this is the point of application of force. Let me call this point as P. So this will be RP. So R vector is nothing but RP minus RA, and RP can be written as 2 I cap plus 3 J cap plus 4 K cap, and RA is 2 I cap. That's it. So this comes out to be 3 J cap plus 4 K cap. Now we got R vector, and now we want to find the torque. So torque will be R cross F. R is 3 J cap plus 4 K cap across with 4 I cap plus 3 J cap plus 4 K cap. So this will be 12 times J cross I will be minus K. Then we have 3 J cross K will be I, so it will be 12 I cap. And then we have K cross I will be J, so 16 J cap. And then K cross J will be minus I, so minus 12 I cap. So this comes out to be minus, this will get cancelled out. So it will be 16 J cap minus 12 K cap. And we have to find the magnitude. So it will be root of 16 square and 12 square. So that will be 256 plus 144. That comes out to be 400, which is 20 Newton meter. So 20 is the answer of this question. Now let us see the next question. A heavy iron bar of weight W is having its one end on the ground and the other on the shoulder of a person. The bar makes an angle theta with the horizontal. The weight experienced by the person is. So here, let me first draw the diagram. So let's say this is the person. And there is a bar, and this bar makes an angle theta with the horizontal, and this bar is resting on the shoulder of the person, right? And the weight experienced by the person. So if we draw free body diagram of the bar, we can say this person will exert a normal reaction force which will be in this direction, and there will be, let us say, a frictional force, let me call this as F, and there will be a normal reaction experienced by this point in the upward direction, let me call this as N1, and there will be a frictional force, let us say F1 in this direction, right? So as per NTA, what they have considered, that the answer is W by 2, where what they mean that the weight experienced by the person does not depends upon theta, so which is incorrect. So actually what should be the answer? Let us see what should be the right answer, right? None of these options are correct. So let us find this N. And there will be a gravitational force acting at the center. That will be W, which is given. So since this bar is in rotational equilibrium, let us find the torque about the point of contact of the bar with the ground, about A. So about A, this W will try to rotate this bar in the anti-clockwise direction, and this normal reaction will try to rotate this bar in clockwise direction, and this frictional force have zero torque about A, right? So from this we can find N in terms of W. So how to find the torque of W? So this is the line of application of W. Its perpendicular distance from point A will be L by 2 cos theta. So the torque of W will be W times L by 2 cos theta. This should be balanced by the torque of normal reaction. So normal reaction line of application is this, and its perpendicular distance is nothing but L from A. So it will be N times L. So normal reaction comes out to be W by 2 cos theta. Right, so the bar is exerting W by 2 cos theta force on the shoulder. So ideally this should be the force experienced by the person, or the weight experienced by the person. Or what you can do, if they want to find the weight in the downward direction, then you can take the component of this force in the vertically downward direction. So that comes out to be W by 2 cos square theta. So none of these options are correct, right? So it should be W by 2 cos theta if you want to find the force normal reaction on the bar by the shoulder. Now let us see the next question, and it is again based on rotational equilibrium. A root 34 meter long ladder weighing 10 kilograms leans on a frictionless wall. Its feet rest on a floor 3 meters away from the wall as shown in the figure. If FF and FW are the reaction forces of the floor and the wall, when we have to find the ratio of the reaction forces, right? So let me show the forces acting on the ladder. So there will be a gravitational force acting at the center of mass, so that will be 100 Newton. There will be a reaction force exerted by the wall, which will be in the left direction, let me call this as N1, and there will be a reaction force exerted by the floor, which is in the upward direction, that will be N2. And this ladder has a tendency to slide in the left direction, so there will be a frictional force in the right direction. So now we want to find N1, N2 and F, and in that case and then we'll be able to find the reaction forces. So what we're going to do, since this ladder is not moving, so we can apply translational as well as rotational equilibrium. In translational equilibrium, forces must balance each other. In case of a rotational equilibrium, the torque about any point will be 0. So if we apply translational equilibrium, N2 will balance 100, and the frictional force from the ground will be equals to N1. Now what we can do, we can apply rotational equilibrium. So let us consider torque about A. So about A, torque of N2 and F will be 0. So we are left with N1 and 100 Newton. N1 will try to rotate this ladder in the anti-clockwise direction, whereas 100 Newton will try to rotate this ladder in the clockwise direction. So we need to balance the torque of N1 and 100 Newton about A. So this is the line of application of N1, and its perpendicular distance from A will be, if this angle is theta, first let us find the angle theta, then we can find the distance of the line of application of N1 from A. So this is 3 meter. So this will be root of 34 minus 9, which will be root 25, which is 5 meter. So we can say this will be 5 meter. So the torque of N1 about A will be N1 times 5. And this is the line of application of 100 Newton, and its perpendicular distance from A will be half of 3, right? That will be 3 by 2. So it will be 100 times 3 by 2. So from this we will get N1, which will be, this will be 50, this will give us 10. So it comes out to be 30 Newton. So we got N1. N2 we have given. So so N1 we got, N2 we got, right? So now we have to find the ratio of the reaction force. So the reaction force from the floor is nothing but the resultant of frictional force and the normal reaction force. So so we can say from the floor F, this is nothing but root of F square and N2 square, and Fw is nothing but N1, right? So we want to find Fw upon Ff, which is N1 divided by root of F square plus N2 square. So what is N1? N1 is 30, and root of F2 square plus N2 square. So F is nothing but N1. N1 is 30. N2 we have and N2 we have calculated, N2 is 100. Okay, let us simplify this. So we have 30. So 10 will come out in the denominator. So we have root of 9 plus 100. So this 0 will get cancelled out. So this comes out to be 3 upon root 109. So option C is the right answer. Another question based on the equilibrium. A solid cylinder of mass m is wrapped with an inextensible light string and is placed on a rough inclined plane as shown in the figure. The frictional force acting between the cylinder and the inclined plane is. So we have to find the frictional force, and coefficient of static friction is given as 0.4. So first let us see the forces acting on the solid cylinder. So there will be a tension force up the incline. There will be a weight in the downward direction, say mg, right? So if this cylinder is in equilibrium, there has to be a frictional force up the incline, right? And it has to be static. So we can say the torque, or if we balance the forces, then we can say T plus F. Let me just resolve the gravitational force in along the inclined plane and normal to the inclined plane. So this component will be mg sine 60, and this component will be mg cos 60, right? And there will be a normal reaction force. So normal reaction force is balancing mg cos 60, and mg sine 60 will get balanced with tension and frictional force. So T plus F will be equals to mg sine 60 degree. And the torque of tension and the frictional force, they should balance each other. So we can say T times R should be equals to F times R. So this comes out to be T is equals to F. So we can say 2 times, and we have to find the frictional force. 2 times F will be mg times, so from this equation 2 times F will be mg sine 60 degree. So this F comes out to be, and what is the maximum value of frictional force? So F max is mu times mg cos 60, which is 0.4 mg, and cos 60 is 1 by 2, so it will be 0.2 mg. Now from this we are getting mg by 1 by 4, which is 0.25 mg, right? So if you're working like this, we can say the frictional force will be 0.25 mg if we consider rotational equilibrium. But if you look at the maximum frictional force, it is 0.2 mg. So we can say this force is greater than 0.2 mg. So it means this cylinder is not in equilibrium, it must be slipping. So slipping will be there. If there is slipping, then the frictional force will be kinetic, right? And then in that case, we can assume that the coefficient of static friction is same as the kinetic friction. So the maximum, so the frictional force will be 0.2 mg. So 0.2 mg, that will be mg by 5. I hope this is clear. So first I have assumed it is in rotational equilibrium. I found the frictional force. It comes out to be greater than the maximum value of the frictional force. So it gives us the cue that there will be a slipping. So the friction will be kinetic, and the kinetic friction will be mu n, and mu n will be 0.4 times mg cos 60. So option 3 is the right answer. Right. So let us say this another question based on the equilibrium. An object of mass 8 kg is hanging from one end of the uniform rod CD of mass 2 kg and length 1 meter, pivoted at its end C. On a vertical wall as shown in the figure, it is supported by a cable AB such that the system is in equilibrium, the tension in the cable. So we have to find the tension in the cable AB. And it is pivoted, right? And it is pivoted at C. So what we can do, so let us first draw the free body diagram of the rod. So at the pivot, let us say there will be a force exerted in the vertically upward direction, and there will be a force in the horizontal direction, right? So whenever we have a hinge or a pivot, we should always assume two forces acting in mutually perpendicular direction, and the resultant of these two forces will be the net force exerted by the pivot on the rod. And there will be a tension force away from the point B in this direction, and there will be a tension force which is nothing but 80 Newton in the downward direction, and the rod is having a mass 2 kg, so there will be a gravitational force at the center of mass which will be 20 Newton, right? So what, and we have to find the tension. So what are you going to do? Try to since it is in rotational equilibrium, let us try to find the torque about C, because if we take point C as our reference point, then the torque of R2 and R1 will get cancelled out. So we'll get only one unknown, which is nothing but T, and we'll get the value of T. So T has two component. So this component will be T sine 30, and this component will be T cos 30. We can say the I'm assuming the rod is thin. The component T cos 30 is passing through the point C, so the torque of T cos 30 will be 0. Now let us find the torque about C. T sine 30 will try to rotate this rod in the anti-clockwise direction with respect to C. 80 and 20 will try to rotate the rod in the clockwise direction. So we can say the torque of 20 and 80 must balance the torque of T sine 30. So T sine 30 times the perpendicular distance of the line of application of T sine 30, which will be 60. That should be equals to 20 times 50 plus 80 times 100. So this 0 will get cancelled out. So it will be T sine 30 is 1 by 2. So T times 3 is equals to 100 plus 800. So T comes out to be 900 by 3, which is 300. 300 Newton is the answer. So option 3 is the right answer. Right, so now the next concept is the rotation about a fixed axis. So let us see the question. A string is wrapped around a rim of a wheel of moment of inertia 0.4 kilogram meter square. The radius is 0.8. Moment of inertia is given, radius is given. The wheel is free to rotate about its axis. Initially, the wheel is at rest. The string is now pulled by the force of 40 Newton. So we have given a wheel which is having a moment of inertia 0.4 kilograms meter square. Now we are pulling, and we have wrapped a string over this wheel, and we are pulling the string with a force of 40 Newton. And due to this pulling, this wheel will rotate in a clockwise direction about the axis of rotation, and the angular velocity of the wheel after 10 seconds is x radians per second. What is the value of x? So here what is actually happening, this 40 Newton torque will apply torque about this axis of rotation. Due to that torque, the wheel acquires some angular velocity, and since it has some angular not angular velocity, angular acceleration, and that angular acceleration will increase the angular velocity. So let us say alpha is the angular velocity and the torque is 40 times the radius, so 0.1, so it comes out to be 4 Newton meter. So that is the torque. So when a rigid body is rotating about a fixed axis, torque is equals to I alpha, where alpha is the angular acceleration about the axis of rotation. So alpha comes out to be tau by I, that will be 4 divided by moment of inertia, that is 0.4. So this comes out to be 10 radians per second square. Now we got angular acceleration, and now we have to find the angular velocity. So here we're going to use the concept of kinematics in rotational motion. So here we want to find omega after 10 seconds. So we can use omega is equals to omega naught plus alpha times t, where omega is the angular velocity at 10 seconds, where omega naught is the initial angular velocity and alpha is the angular acceleration, t is the duration. So this will be 0 plus alpha is 10 and the time is 10. So this comes out to be 100 radians per second. So 100 is the answer. Another question based on the rotation about fixed axis. A uniform disc of mass m, which is 4 kilograms and radius 10 centimeter, is mounted on a fixed horizontal axle as shown in the figure. A block of mass 2 kg hangs from a massless cord that is wrapped around the rim of the disc. During the fall, the block, the cord does not slip and there is no friction at the axle, the tension in the cord. So we have to find the tension. And the disc has a mass m, so disc has moment of inertia, right? So we can say the moment of inertia will be mr square by 2, which will be 4 by 2 times 0.1 square, so that will be 2 times 10 raised per minus 2 kilogram meter square. So we got the moment of inertia of the disc. So what is actually happening in this case, let us say the block is going down with an acceleration a. If this so we can say this point on the string is also going down with an acceleration a, and if I consider a point on the disc, this point is will be having an acceleration which will be r alpha, if we assume alpha is the angular acceleration of the disc. So this point is having an acceleration r alpha. So a will be equals to r alpha because this string is not slipping over the disc. So we can so this is the relation between a and alpha. So we can say a will be r is 0.1 times alpha. So if we apply torque equation for the disc, so we have a disc, there is a force, there is a tension T, and due to this tension there will be an angular acceleration. So we can say T times R will be equals to I alpha. So T times R will be 0.1 and I is 0.02, and alpha can be written as 0.1, sorry, it can be written as 10 times A, 10 times A from this equation. So T will be 0.2 divided by 0.1 times A, which is 2 times A. So we got tension equals to 2A, and if we apply Newton's second law for the block, so on the block there will be a gravitational force acting in the downward direction. Tension is acting in the upward direction, it is having an acceleration in downward direction. So the net force in the direction of acceleration is mg minus t, which will be mass times acceleration, and mass of the block is 2 kg. So it will be 20 minus t is equals to 2 times a, and a is t by 2. So from this t comes out to be 10 Newton, right? So answer will be 10. Now let us see this question. A disc of mass 1 kg and radius r is free to rotate about an horizontal axis passing through its center and perpendicular to the plane of the disc. A body of same mass as that of the disc is fixed at the highest point of the disc. Now the system is released when the body comes to the lowest position. Its angular speed will be 4 times root of x by 3r. We have to find the value of x and we have to take g as 10 meters per second square. So let us see. So there is a disk and it is free to rotate about a horizontal axis. That is the axis. And there is a body which is attached to this disk at the highest point, so which is having a mass m, 1 kg, and this disk also has a mass 1 kg. Now we have released this system. Now this mass will come down to the bottom, right? So the disk has rotated by half a rotation, right? And the mass has come down. So what is happening? What is happening in this question? There is a decrease in gravitational potential energy and the gain in rotational kinetic energy. So the rotational kinetic energy is defined as half I omega square, where I is the moment of inertia about the axis of rotation. So if we do that, so here we can apply loss in gravitational potential energy equals to gain in kinetic energy. So loss will be mg2r because it has come down by a distance 2r or vertical distance 2r. So it will be 1 times g times 2 times r, okay, right, I'm keeping it r only, and the gain in kinetic energy. So let us find the moment of inertia of the system about O. So that will be moment of inertia of the disk plus the moment of inertia of the particle which is at the periphery. So it will be m r square by 2 plus mr square. Mr square is the moment of inertia of the point at the periphery about this axis. So this will be 3 by 2 mr square. So it will be 3 by 2 times 1 r square. So we can say it will be half I naught, which will be 3 by 2 r square times omega square, and we have to find the angular velocity. So let us simplify this. 1 r will get cancelled out. So we'll got 20 times 4 by 3, root of that will be omega. Or we can write, and r is also there, right, in the denominator. So this can be written as 4 will come out and it will be 5 upon 3r. So if we compare, x will be 5. So 5 is the answer of this question. So whenever we have to find the angular velocity in rotation, we always have to conserve energy mechanical, or you can apply work energy theorem. So now let's say this question. A solid cylinder length is suspended symmetrically through two massless string as shown in the figure. The distance from the initial rest position of the cylinder should be by unbinding the strings to achieve a speed of 4 meters per second. So distance from the initial rest position, the cylinder should. So I think they're asking what should be the displacement of the center of mass when the center of the cylinder acquire a speed of 4 meters per second. Right? So if I look at this problem, look at this cylinder from the left, it looks like a disc to me. And if I show the forces acting on this, so there will be two strings, and by symmetry we can say both the string will be having same tension. So I can say we have 2T acting in this direction. There will be a weight mg in the downward direction. Right? So so the speed of the center of mass is 4 meters per second. And we have to find the distance from the initial position. So let us say it has come down. A distance x, and when it comes down by a distance x, there will be the velocity acquired will be 4 meters per second, right? And we can say the cylinder is rolling purely, right, about this particular point. So we can say this v is equals to r omega. Got it? So what we can say, there will be a loss in gravitational potential energy and it will be equals to gain in kinetic energy. Now here we have rotational as well as translational kinetic energy. So loss in the gravitational potential energy will be mgx, and this x we have to calculate, and the gain in kinetic energy will be half I, that will be I omega square plus half mv square. So half I, and omega can be written as v by r, half mv square, and I can be written as, it's a solid cylinder, so mr square by 2. So v square by r square plus half mv square. So r square will get cancelled out. So it will be 1 by 4 plus 1 by 2 mv square, and this will be equals to mgx. So m will get cancelled out. So g is given as 10. So this will be 3 by 4 times v square, and v is given as 4. So this will give us 4. So 12 by 10, that will be x. So it comes out to be 1.2 meters or 120 centimeters. So 120 is the answer of this question. So I hope this concept is clear to you. Now let us see the next question. A pulley of radius 1.5 meter is rotated about its axis by the force which is 12t minus 3t square. Apply tangentially. If the moment of inertia of the pulley about its axis of rotation is 4.5 kilograms meter square, the number of rotation made by the pulley before its direction of motion is reversed will be k upon pi. So there is a pulley and we are exerting a force, and if you look at this force, it is a function of the force is a function of time. So what is the torque? So we can find the torque, which will be 12t minus 3t square times the radius, and radius is 1.5, or I can write this as 3 by 2. So this will give us 6t minus 1.5t square times 3, or I can write this as 18t minus 4.5t square. Right, so if you look at the tension, we can say initially the tension will be positive. Sorry, no tension. The torque will be positive, and then its sign will also change. So that's why the direction of motion will also reverse. So torque is equals to I alpha. So I in this case is 4.5, and this will be alpha, right? Now we got alpha as a function of time. So we can write this as 18 by 4.5 times t, 4.5 by 4.5 times t square. So that is alpha. This will give us 4. This is 1. So 4t minus t square. Now alpha can be written as d omega by dt, or we can also write this as omega d omega by d theta, right? Because we have a non-uniform motion. So we can use this. So let us use the second formula. So we can write omega d omega by d theta as 4t minus t square. And we have to find the number of rotations made by the pulley before its direction of motion is reversed. So when the direction of motion will reverse, at that instant the angular velocity will become 0, right? So omega d omega will be equals to okay, right? So omega we have to calculate, we have time. So what we can do, let us first find omega as a function of time. Okay, let me use the first formula. Let me take d omega by dt. So this will, so let us find omega. So this will be 4t minus t square times dt. So if we integrate this from 0 to omega, let us say at t the omega, like at t the angular velocity is omega. So it will be omega equals to 4t square by 2 minus t cube by 3. So that will be 2. So it will be 2t square minus t cube by 3. Now we got omega. So now from the omega, and when do we have omega to be 0? Let us see. So this can be written as t square will be common. So 2 minus t by 3. Now from this we can say omega will be 0 at t equals to 6 seconds or 0 seconds. So we can say at t equals to 6, the direction, the omega will become 0, right? So we have to find the angular displacement from 0 to 6 seconds. So d theta by dt can be written as 2t square minus t cube by 3, or d theta will be 2t square minus t cube by 3 times dt. So if we integrate this from 0 to theta, from 0 to 6, because after 6 seconds the angular velocity will become 0, and then the body will try to reverse its motion. So this will be 2t cube by 3 minus t raised to power 4 by 12, and the limit is from 0 to 6. So let us substitute the value. So this will be 2 by 3 times 216 minus 6 raised to power 4. So that will be 216 times 6 divided by 12. So this will be 2. So this comes out to be 2 times 72 minus 108. So it will be 144 minus 108. And we have to find the so this will be the answer in radians. So it will be 34. So 34 radian, and we have to find the number of rotations. So number of rotations will be theta by 2 pi. So which will be 34. Let me check. It will be 144 minus 108. 72, 144. Sorry, this will be 36, not 34. This will be 36. So 36 divided by 2 pi, so which comes out to be 18 by pi. So if you compare with this k by pi, so k comes out to be 18. So 18 is the answer of this question. So now let's see the next question. The angular speed of a truck wheel is increased from 900 rpm to 2460 rpm in 26 seconds. The number of revolutions by the truck engine during this time is. Okay, right. So, and we have given acceleration is uniform. So when the acceleration is uniform, we can use, let me write down the formulas which we can use, equations of motion which we can use. We can use omega is equals to omega naught plus alpha t. We can use omega square is equals to omega naught square plus 2 alpha theta, or we can use theta is equals to omega naught t plus half alpha t square, or we can use average angular velocity will be omega plus omega naught by 2, and the angular displacement can be written as average angular velocity times the duration. So now we have to figure out like which formula we have to use for this particular questions to solve this question in the least amount of time. So the number of revolutions by the truck engine during the time. So we want to find theta, right? Number of revolutions. So we can find theta in radians by using this relation, and we have given RPM. So RPM is revolutions per minute. So we can find revolutions per second, right? So we can use this formula where omega average will be omega plus omega naught by 2, where omega naught is the initial angular velocity, omega is the final angular velocity, and right. So let us use this. So omega will be, so I'm using omega as revolutions per second. So this will be 900 by 60 to 2460 by 60. So this will be in revolutions per second. Revolutions per second, because we want to find revolutions. So it will become 2460 plus 900 divided by 2 multiplied with 60. Right. So this is the average angular velocity in revolutions per second. Multiply this with the time duration, that is 26. So this will give us the number of revolutions. So it comes out to be 3360 divided by 2 into 60 times 26. So this will give us 13, and this will give us 56. So 56 times 13 will be 728. So there will be 728 revolutions in 26 seconds. So 728 is the answer. Right. So let us see the next question. Consider a 20 kg uniform circular disc of radius 0.2 meters. It is pin support at its center and is at a rest initially. The disk is acted upon by a constant force of 20 Newton through a massless string wrapped around its periphery as shown in the figure. Suppose the disk makes an n number of revolutions to attain an angular speed of 50 radians per second. The value of n to the nearest integer and we have given in one complete revolutions the disk rotates by 6.28 radians. Right, so we have to find the number of rotations or number of revolutions and the omega is varying from 0 to 50 radians per second, right? Force is given, so we can find the torque, right? So we can find torque, so torque will be F times the radius, which is 0.2, so it comes out to be 4 Newton meter. Then we can find the angular acceleration, and it's a circular disk. Radius is given, mass is given, so we can find the moment of inertia. So that will be m r square by 2. Mass is 20, radius is 0.2, so that will be 4 into 10 raised to power minus 2 divided by 2. So this will give us 4 into 10 raised to power minus 1 or 0.4 kilogram meter square. So we got moment of inertia. So alpha will be torque divided by the moment of inertia. So that will be 4 divided by 0.4. So this comes out to be 10 radians per second square. So we got alpha and we want to find the number of revolutions. So let us find the angular displacement, right? So I'm going to use omega square equals to omega naught square plus 2 alpha theta. So from this omega naught is 0, omega is 50. So 50 square divided by 2 times alpha, alpha is 10. So we got angular displacement in radians. Now we want to find the number of revolutions. So if we divide angular displacement with 2 pi, we will get the number of revolutions. So this will be 2500 divided by 20. Divide this with 2 pi, right? So this will give us, so let us find the answer. So this will be 25 divided by 4 divided by 6.28. 6.28 and we have to find the value of n. Let me check it again. 250, na? 250 divided by 2 divided by 2 pi. Oh, sorry. So it will be 250 divided by 4 divided by pi, which will be 3.14. So it comes out to be 19.9, which is nearly equals to 20. So the answer will be 20. So that's what we have to take. So 20 is the answer. Now let us see this question. A thin uniform rod of length 2 meter, cross-sectional area A and density D. So cross-sectional area is given, density is given, and length is given, is rotated about an axis passing through the center and perpendicular to its length with an angular velocity omega. If the value of omega is in terms of its rotational kinetic energy is root of alpha E by AD, then the value of alpha is, so the rotational kinetic energy is half I omega square. So half I will be, it's a uniform rod, right? And for the rod, the moment of inertia about the axis passing through its center will be ml square by 12. So we can say ml square by 12 times omega square. So here mass can be written as density times the volume, and volume will be area of cross section times the length. So it can be written as 1 by 24 times dA times 2, that is m. L is 2, so that will become 4 omega square. So that will be E. So 4 2s are 8 and this will be 3. So omega can be written as 3E upon dA, root of this, right? So if we compare, this alpha comes out to be 3. So 3 is the answer. Now let us see the next question. In a given figure, two wheels P and Q are connected by a belt B. The radius of P is 3 times as that of Q. In case of a same rotational kinetic energy, the ratio of rotational inertia I1 by I2 will be x ratio 1 and the value of x will be. So here I'm assuming that this belt is not slipping on these two wheels. So what we can say, if you consider this particular point, so this point on this point will be having, so let us say it is rotating with an angular velocity omega 1. Now this omega 1, so this point will be having a velocity r omega 1, that will be 3 r omega 1. Similarly, this point on the other disk will be having a velocity r omega 2. Let us say angular omega 2 is the angular velocity of the other wheel. And since and every point on the belt will be having the same velocity along the belt, because the distance between any given 2 points is not changing, so we can say the speed will be same. So 3 r omega 1 will be equals to r omega 2, or we can say omega 1 by omega 2 will be 1 by 3, right? So we have to find the ratio of rotational inertia if they have same rotational kinetic energy. So what we can say, so the kinetic energy of the first wheel will be half I1 omega square, that will be omega 1 square, and that is equals to half I2 omega 2 square. Now from this, I1 by I2 will be omega 2 by omega 1 square, and omega 2 by omega 1 is 3 by 1. So this comes out to be 9 ratio 1. So the answer will be 9. Right, so let us see this question. A cord is wound around the circumference of a wheel of radius r. The axis of the wheel is horizontal and the moment of inertia is I. A weight mg is attached to the cord at the end. The weight falls from rest. After falling through the distance h, the square of the angular velocity of the wheel will be. So what we have given, moment of inertia of the wheel is given. So there is a wheel and a cord is wrapped around this wheel, and the one end of the cord is connected with the block of mass m or weight mg, right? So mass is m. So it is going down. Let us say when it has gone down by a distance h, the angular velocity of the wheel is omega. Again, the cord is not slipping on the wheel, so we can say the velocity of the block, which is v, right? When it reaches at this particular mark, its velocity is v, right? So this point is going down with v, and the point on the disk at the periphery is going down with the velocity r omega. So v will be equals to r omega if the cord is not slipping. So we can apply this. Now we can apply energy conservation. Small m is going down by a distance h, so there is a loss in gravitational potential energy and the gain in kinetic energy of the block as well as of the wheel. So what we can do, mgh is the loss in gravitational potential energy, and the gain in kinetic energy will be half mv square plus half I omega square, and we have to find square of the angular velocity. So v can be written as r omega. So this will be half m r omega square plus half I omega square. Now from this, m r square by 2 plus I by 2 times omega square, so that will be mgh. So we can write this as 2 mgh divided by mr square plus I. So that will be the square of the angular velocity. So if you look at the option 2 is the right answer. Right, so let us say this question. A light rope is wound around the hollow cylinder of mass m. So mass 5 kg and radius 70 centimeter. The rope is pulled with a force of 52.5 Newton. The angular acceleration of the cylinder. So there is a cylinder and it is free to rotate about this axis, and we are exerting a force of 52.5 Newton. And due to this force, there will be a torque about the axis of rotation. So the torque will be 52.5 times the radius. Radius is 0.7. So it will be in Newton meter. And we have to find the angular acceleration, that will be torque upon moment of inertia. And it's a hollow cylinder. For hollow cylinder, moment of inertia is mr square. Mass is 5 and it will be 0.7 square. So it will be 52.5 times 0.7 divided by 5 into 0.7 square. So 0.7 will get cancelled out, and this will give us 10.5. So it will be 105 by 7, right? Which is nothing but 15. So 15 radians per second square. So 15 is the answer, right? So let us see this question based on the another problem type, which is impulse momentum theorem. A uniform rod AB of mass 2 kg and length 30 centimeter at rest on a smooth horizontal surface, an impulse of force which is 0.2 Newton second. So impulse is 0.2 Newton second is applied to the end B. The time taken by the rod to turn through a right angle will be pi by x. What is the value of x? So let us see what we have given. So there is a horizontal table and there is a rod. This is A and this is B, and we are applying an impulse. So the direction of impulse is not given, and usually the impulse in most of the problems, impulse is being exerted normal to the rod. So I'm assuming that the impulse is acted in this particular direction. So when we have a rod which is free to move on a plane, in that case the center of mass will also acquire linear velocity and there will be an angular velocity. So when this impulse is not acting on the center of mass, there will be an angular velocity acquired by the rod, which will be omega, and that let us say the center of mass has acquired a velocity v in the forward direction, and this impulse is 0.2 Newton second. Now what is impulse momentum theorem? So impulse, I am denoting this with J, will be equals to change in linear momentum, and the angular impulse will be equals to change in angular momentum, right? So first let us and we have to find the angular velocity, right? So we are going to use angular impulse, right? So it will be 0.2, and I'm finding the angular impulse about the center of mass. So this perpendicular distance will be 0.3 by 2. So 0.3 by 2 equals to change in angular momentum. So the angular momentum will be I omega, right? So in this case, it will be moment of inertia about the axis passing through the center times the omega. So that what we have to calculate. So moment of inertia about the axis passing through the center will be ml square by 12. Mass is 2, L is 0.3 square by 12 times omega. So omega we have to calculate first. So it will be 0.1. So it will be 0.03 times 12 divided by 2 times 0.3 square, or I can write this as 0.3 times 0.3. So this will give us 10. This will be 6. So 6 by 3 will be omega. So that will be 2. So omega is 2 radians per second. And with this omega, this rod is getting rotated about the axis passing through the center. And let us say after some time, the rod has rotated by an angle 90 degree. So it will become horizontal. And it is keeps on rotating with the same omega. So we can, and it will be a, you can say uniform accelerated motion, right? It will be having a uniform angular velocity, not a uniform accelerated, it will be uniform angular velocity. So it will be omega t will be equals to theta, and theta, so omega is 2, time we have to calculate, and theta is pi by 2. So t comes out to be pi by 4, which is given as pi by x. So x will be 4 seconds. So not 4 seconds, it will be 4. So 4 is the answer of this question. Right. So now let us see the problem type where I'm going to discuss pure rolling. So a solid circular disc of mass 50 kilograms rolls on a horizontal floor so that its center of mass has a speed of 0.4 meters per second. The absolute value of the work done on the disc to stop it. So when we have a body which is undergoing pure rolling motion on a horizontal surface, right? On a horizontal surface, let us say the center is going in the forward direction with a velocity v, and it is having an angular velocity omega, and we know that in pure rolling motion v is equals to r omega. So the kinetic energy in a pure rolling motion is half mv square times 1 plus k square by r square, where k is the radius of gyration. So what is the question? It says the absolute value of work done on the disk to stop it. So let us say the work done by the external agent will be equal to change in kinetic energy, right? So final kinetic energy will be 0 minus initial kinetic energy will be half mv square times 1 plus k square by r square. So I have applied work energy theorem to find the work done to stop the disk. Now for the disk, k square by r square is 1 by 2. So this is nothing but minus of 1 by 2 mv square times 1 plus 1 by 2. So that will become 3 by 4 mv square, and we have to find the modulus. So the modulus of this will be 3 by 4 mv square. Mass is 50, v is 0.4, so 0.4 times 0.4. So this will give us 0.1, so this will give us 5. So we have, and this will be 2 by 5, so 5 will get cancelled out, so it will be 6 joules. So 6 joules will be the answer of this question. A ring and a solid sphere rolls down an inclined plane. So it is the question based on the inclined plane. So let me just quickly give you some important facts about that. If there is a body with a circular outline which is having a mass m, radius of gyration is k, right, and the radius is r. So if it is rolling down without slipping, in that case the acceleration will be given as g sine theta upon 1 plus k square by r square. So that is the acceleration down the incline, and the friction will be given as mg sine theta upon 1 plus r square by k square, and the minimum coefficient of friction required to prevent slipping down the incline, it will be tan theta upon 1 plus r square by k square. So this data you have to remember. And if the body is rolling up the incline, the acceleration doesn't change, so you can use the same formula. So if there is a body which rolls up and rolls down, so the time taken for the body to go up is same as the time taken by the body to roll down. So that you can remember. So the radii of both the bodies are identical. So radius is given same, and the ratio of kinetic energy is. So we are releasing the body from the same height, right? And this starts from rest. The radii of both the bodies are identical. Ratio of kinetic energy we have to calculate. So what we can say, if and no information is given about the masses, so let us assume, so I'm assuming that both have the same mass, right? No, that information is not given. So as they're coming down, the loss in gravitational potential energy will be same. So if the loss of gravitational potential energy is same, then we can say the gain in kinetic energy will be same. So it should be 1 raised to 1, right? So which is 7 by x. So that should be given in this question. Their masses should be given equal, which is not given. So it should be, so the answer will be 7. A hollow sphere is rolling on a plane surface about its axis of symmetry. The ratio of rotational kinetic energy to the total kinetic energy. So rotational kinetic, let me just tell you again some important formulas. So the total kinetic energy in pure rolling motion on a horizontal surface or any surface will be half mv square 1 plus k square by r square, where k is the radius of gyration, and the rotational kinetic energy will be half I omega square, which can be written as mk square omega square, right? Or we can also write this as half m k square, and this will be v square by r square. So this will be half m v square k square by r square. And the translational kinetic energy will be half m v square, right? So this you can remember. So here we have to find the ratio of rotational kinetic energy to the total kinetic energy. So rotational to the total. So it is nothing but k square by r square upon 1 plus k square by r square. And we have given a hollow sphere. In case of a hollow sphere, k square by r square is 2 by 3. So 2 by 3 upon 1 plus 2 by 3. So that will be 2 by 3 times 3 by 5. So which is 2 by 5. So the answer will be 2. Right? Let us this question, for a rolling spherical shell, the ratio of rotational kinetic energy to the total kinetic energy. Same question, right? Rotational to the total. So I'm keeping this as a homework. Again, the answer is 2. Solid sphere, spherical ball is rolling on a frictionless horizontal plane surface about its axis of symmetry. The ratio of rotational kinetic energy to the total kinetic energy. Again, I'm keeping this as a homework, right? The answer is A. A boy is rolling a 0.5 kilogram ball on a frictionless floor with a speed of 20 meters per second. The ball gets deflected by an obstacle on the way. After deflection, it moves with 5% of its initial kinetic energy. What is the speed of the ball now? So we have to find the speed. So the original kinetic energy was half mv square 1 plus k square by r square, which is half 0.5 20 square. It's a ball, right? So when a ball is given, you can treat it like a solid ball, right? And solid ball has a, so k square by r square for a solid ball will be 2 by 5. So that will be 2 by 5. So which comes out to be 1 by 4 times 400 times 7 by 5. So this will be 100, which will be 20, 140, 140 joules. 5% of its initial kinetic energy. So after deflection, it moves with 5% of its initial kinetic energy. So 5% of initial kinetic energy is 140. So it will be half mv square 1 plus k square by r square we can apply. So this comes out to be 5 by 100 times 140 times 2 divided by m. M is 0.5. V we have to calculate. 1 plus k square by r square will be 7 by 5. So this will be v square. So this will give us 20, and this decimal will get cancelled out. This will give us 2. So this will give us 10. 5 will get cancelled out. So this comes out to be 20. So v square, so v will be root 20. So which is slightly over 4, right? So option 2 is the right answer. Okay, right. So a uniform disk of mass 0.5 kilograms, radius r, is projected with a velocity 18 meters per second at t equals to 0 on a rough horizontal surface. It starts off with a purely sliding motion at t equals to 0. After 2 seconds, it acquires a purely rolling motion. The total kinetic energy of the disk after 2 seconds. So we have given that it starts rolling purely after 2 seconds, and we have to find the total kinetic energy. So what we can do in this case, so there are two approaches. So let us see the easiest one. If we are able to like in a combined motion, if you know the concept of angular momentum. So if I take a point, say P, right? So the frictional force is acting in the backward direction, that is the kinetic frictional force. So if we consider point P, the torque of the forces about this point P will always be 0. So we can conserve angular momentum for this combined motion about point P. So here, when a body, in this case there is no angular velocity, so we can say the angular momentum about point P will be mv times the radius, right? That will be mvr, and it will be in the into the plane. It will be into the plane, and that should be equals to now it will be having a velocity v, and this will be omega, and v is equals to r omega because it is rolling purely. Now here, if we, it has a combined motion. So for a point mass, the angular momentum is r cross mv. So here it will be mvr plus the angular momentum of the body about the axis passing through the center, which will be I omega, and I in this case it's a uniform disk, so it will be mr square by 2 times omega. Omega can be written as v by r, so it will be mr times 18. This will be mvr plus m by 2 times r square times omega can be written as v by r. So this will be 3 by 2 mvr. So mr times 18 will be 3 by 2 times mvr. So mr will get cancelled out. This will give us 6. So v comes out to be 12. So we got 12 meters per second. So this velocity is 12 meters per second. Now we need to find the kinetic energy. So kinetic energy will be half mv square 1 plus k square by r square. And since it's a uniform disk, k square by r square will be 1 by 2. So it will be half m is 0.5. V square will be 144. 1 plus 1 by 2. So this will be 72, and this will give us 36. So 36 times 5 by 2, so that will be 18, and this comes out to be, no, sorry, 3 by 2. This will be 3 by 2. So this will be 54. So 54 joule is 54 is the answer, right? Now let us see this question. A solid sphere of mass 2 kg is making pure rolling on a horizontal surface with a kinetic energy of 2240 joules, the velocity of the center of mass. Again, I'm going to use the same formula, half mv square 1 plus k square by r square, where k square by r square is 2 by 5 for a solid sphere. So this is 2240. Half m is 2, v square 1 plus 2 by 5, 2 will get cancelled out, so 2240 times 5 by 7. So this will be 320 and it will be 1600. That will be v square, so v comes out to be 40 meters per second. So 40 is the answer. Right, so let us see this question. The center of a wheel rolling on a plane surface moves with a velocity speed v naught. A particle on the rim of wheel at a same level as the center will be moving at a speed of root x v naught, then the value of x will be. So let us see this concept. So there is a wheel which is rolling purely. So this is v naught, and the angular velocity will be v naught by r. And there is a particle which is sticking to the periphery, and it is at the same level of the center of mass, and we want to find the velocity of this particle. So what you have to what is happening in this case, we have a combined motion, so we can split this motion as pure translational and pure rotational, right? So if we consider pure translational motion, then every particle on the periphery will be having velocity v naught. So center is going in the right direction v naught, this is v naught, right? Topmost point v naught, leftmost point v naught, the point of contact with the ground is v naught. And if we consider pure rotational motion about the axis passing through the center of mass, then every particle on the periphery will be having a uniform circular motion, and the angular velocity will be omega. So we can say this particle will be having r omega in this direction, this particle will be having r omega in the downward direction, r omega in the left direction, leftmost particle will be having r omega in the upward direction. Now we have to superimpose these two velocities, and that will give us the net velocity of the points on the periphery. So if we superimpose these two motions, then we can say the rightmost point will be having two velocities. One will be v in the right direction, and there will be r omega in the downward direction. And we know that since it is rolling purely, r omega is nothing but v. So we can say the velocity of the point, say p, will be v naught and v naught, right? So that will be nothing but root 2 times v naught, the resultant of these two. So, and this is given as root x times v naught. So x is 2. So 2 is the answer of this question. So let us see this question. A disc of radius r, mass m is rolling horizontally without slipping with speed v. It then moves up on inclined smooth surface as shown in the figure. The maximum height that the disc can go up. So it's a smooth surface, right? So we can, if it's a smooth surface, inclined surface is smooth, then we can say it cannot exert any frictional force. So it means the rotational kinetic energy will not change, only the translational kinetic energy can change. So at the highest point, the translational kinetic energy will become 0. So we can say loss in translational kinetic energy will be gain in gravitational potential energy, right? And here one more assumption I am taking, that since the disk is changing its direction of motion, so when it changes the direction of motion from this to this, there is no loss of energy, right? So I am assuming that. So loss in translational kinetic energy, which will be half mv square, will be gain in gravitational potential energy, which is mgh. So m will get cancelled out, and we have to find the maximum height. So it will be v square by 2g. So option 3 is the right answer. Right, so let us see this question. A cylinder is rolling down an inclined plane with an inclination 60 degrees. Its acceleration during rolling down will be x by root 3. So we know if a body with a circular outline is rolling down the incline, acceleration is given as g sine theta upon 1 plus k square by r square. And since it's a cylinder, and if nothing is given, like whether it is a hollow or solid, you should always take it as a solid cylinder. And in case of a solid cylinder, k square by r square is 1 by 2. So it will be 10 sine 60 divided by 1 plus 1 by 2. So it will be 5 root 3 divided by 3 by 2. Or we can write this as 10 divided by root 3. So x will be 10. So 10 is the answer. Right, so let us see this question. A solid sphere and a hollow sphere rolls up without slipping on the same inclined plane with the same speed v. The sphere and the cylinder reaches up the maximum height h1 and h2 respectively above the initial level. The ratio h1 and h2 of h1 and h2 is n by 10, the value of n. So we have to find the height. So we can say the loss in kinetic energy will be converted into gravitational potential energy. So it will be so mgh1, that is for the sphere, will be equals to half m v square 1 plus k square by r square, which will be for solid sphere, it will be 2 by 5, right? And the same thing we can do for hollow cylinder. So mgh2 will be half mv square, and for hollow cylinder k square by r square will be 1 by 1 only, right? So let us take the ratio. So h1 by h2 will be 7 by 5 by 2, so which will be 7 by 10, and this is given as n by 10, so n comes out to be 7. Right, so let us see the next question. A circular disc reaches from the top to bottom of the inclined plane of length L. So there is an inclined plane and there is a disc, and it is coming down, and this length is given as L. When it slips down the plane, it takes t seconds. Slips down means the acceleration is g sine theta. When it rolls down the plane, then it takes alpha by root of alpha by 2 times t. So we have to find alpha. When it is rolling down, in that case the acceleration will be g sine theta upon 1 plus k square by r square, and since it's a circular disc, k square by r square will be 1 by 2. So that is the acceleration, right, in the second case when it is rolling down. Or you can say 2 by 3 g sine theta. Now we can use kinematics. We know the acceleration, displacement is given, so we can find the time by using s is equal to ut plus half at square. So s will be L, u will be 0, half a will be 2 by 3 g sine theta times t2 square. So t2 square will be 3L by g sine theta, right? Similarly, we can find the time when it is sliding down, when the acceleration is g sine theta. So in that case, L will be half g sine theta t square. So this will be 2L upon g sine theta, that will be t square. Now let us take the ratio of these two, right? So t2 by t1, t2 by t square will be 3L by g sine theta upon 2L by g sine theta. So g sine theta will cancel out, L will get cancelled out, this will be 3 by 2. So t2 by t will be root of 3 by 2. So take this t on the other side. So it is given as root of alpha by 2 times t. So alpha is 3, right? So 3 is the answer of this question. Right, so let us see this question. A hollow spherical ball of uniform density rolls up on a curved surface with an initial velocity 3 meters per second, maximum height with respect to the initial position covered by it. So here it is rolling up. So if it is rolling up, right, so what we can say, the curved surface will have friction. So at the highest point, rotational as well as the translational kinetic energy both will become 0. So we can say loss in kinetic energy will be gain in gravitational potential energy. So we can say mgh will be equals to half m, and it's a hollow sphere, mv square 1 plus k square by r square, and it's a hollow spherical ball. So for k square by r square will be 2 by 3. So this comes out to be 1 by 6 mv square times 5. That will be mgh. So m will get cancelled out. V is given as 3. So it will be 9 by 6 times 5 divided by 10. So 3, 2. So this will be 3 by 4. So h will be 3 by 4 meters. And we have to find answer in centimeters. So 3 by 4 times 100. So that will be 75 centimeters. So 75 is the answer. A rolling wheel of mass 12 kg is on an inclined plane at position P and connected to a mass of 3 kg through a string of a fixed length and pulley as shown in the figure. Consider PR as a friction free surface. So there is no friction on PR. The velocity of the center of mass of the wheel when it reaches at the bottom Q of the inclined plane where PQ will be 1 by 2 root xgh. Right, so what is happening in this case? The wheel is rolling down and the block is sliding up. Again, what I can do, we can do energy conservation. The center of the wheel is coming down vertical displacement of the center of wheel will be h, and the vertical displacement of the block in the upward direction will be h. So we can say loss in the gravitational potential energy of the wheel is getting converted into gravitational potential energy of the block and the kinetic energy of the block and the wheel. So no information is given about the wheel, whether it's a disc or a ring. So I'm assuming it to be a ring. So let us try to find the answer by considering this wheel as a ring. So loss in gravitational potential energy of wheel is equals to gain in kinetic energy of wheel plus gain in kinetic energy of block plus gain in gravitational potential energy of block. So loss in gravitational potential energy of wheel will be 12 times g times h, and the gain in kinetic energy of wheel is doing pure rolling motion. So if when it reaches the bottom, if it has a velocity v in this direction, block will reach the top and it will be having a velocity v in the upward direction. So this can be written as half 12 v square 1 plus k square by r square, and k in case of wheel I'm assuming it to be a ring, so it will be 1. And then the gain in kinetic energy of the block, which will be half times 3 times v square, and then the gain in gravitational potential energy of the block, that will be 3 g h. So let us try to simplify this. This will be 6. So we got 9 g h. I have taken 3 g h on the left hand side. So it will be 12 plus 3 by 2 v square. So this comes out to be 25, 27 by 2 v square 9 g h. So this will be 3. So it will be 2 g h by 3 is v square, and if you take the root and this is given as 1 by 2 root x g h will be root of 2 g h by 3. So let us eliminate g h and let us take the square. So x by 4 is equals to 4 or 2 by 3. So it comes out to be 8 by 3, which is 2.67, right? So if we consider this wheel just like a ring, then the answer x, if it is an integer type question, then the answer is close to 3, right? So 3 should be the answer of this question. And suppose if I consider this wheel as a disc, then obviously the answer will change. So answer should be 3, right? If I'm considering this wheel as a ring. Right, so let us see the next question. A solid cylinder and a solid sphere have the same mass m and radius r, rolls down the same inclined plane from the top without slipping. They start from rest. The ratio of the velocity of the solid cylinder to that of the solid sphere with which they reach the ground. So we have to find the velocity at the bottom, right? Ratio. So here we are releasing them from the same height, so the kinetic energy will be same. So we can say kinetic energy of solid cylinder will be same as the kinetic energy of solid sphere, and they have same mass and same radius, so it will be half m v square 1 plus k square by r square. For solid cylinder it will be 1 by 2, and it will be half m, let me call this as v1, right? Half m v2 square 1, for solid sphere k square by r square will be 2 by 5. So half m will get cancelled out, so we have v1 square times 3 by 2, v2 square times 7 by 5. So v1 by v2 square will be 14 by 15. Now we have to take the root of this, so it is option D is the right answer. Right, so the following bodies, a ring, a disc, a solid cylinder, a solid sphere of same mass and radius, are allowed to roll down without slipping simultaneously from the top of the inclined plane. The body which reaches first at the bottom of the inclined plane. So the body which will be having the maximum acceleration will reach the bottom first. So we know that acceleration is given as g sine theta upon 1 plus k square by r square. Let us find the value for acceleration for different bodies. So g sine theta is same in all the cases. So in this case, k square by r square for ring will be 1. It will be g sine theta by 2 in acceleration in case of ring. In case of disc, it will be 2 by 3 g sine theta. In case of a solid cylinder, it is same as disc, 2 by 3 g sine theta. In case of a solid sphere, k square by r square is 2 by 5. So that will be 5 by 7 g sine theta. So let us find the numerical value. So it will be 0.5 g sine theta. This one is 0.67, 0.5, 0.67, 0.67. This will be 0.771, right? So we can clearly see that in case of a solid sphere, we are getting the maximum acceleration. So solid sphere will reach the bottom first. So the answer will be 4. Right? Right, so sphere of mass 2 kg and radius 0.5 meter is rolling with the initial speed of 1 meters per second, goes up an inclined plane which makes an angle of 30 degree with the horizontal plane without slipping. How long will the sphere take to return to the starting point? So time of ascent will be same as the time of descent. So let us find the time of ascent, and we multiply that with 2, we'll get the answer. So it is rolling up and the speed is 1 meters per second. So angular velocity omega, which is v by r. Radius is given as 0.5, mass is also given. So acceleration, so the retardation in this case will be g sine theta upon 1 plus k square by r square. So acceleration, retardation will be g sine theta, so sine 30 divided by 1 plus, it's a solid sphere, so 2 by 5. So 5 by 7 g sine 30. So at the highest position, velocity as well as angular velocity becomes 0. And we have to find the time. So we can use v is equals to u plus at. So final velocity is 0, initial velocity is 1. Acceleration will be minus 5 by 7 g sine 30 times t. So t comes out to be 7 by 5 g sine 30. So which will be 7 by 5, g will be 9.8 and sine 30 will be 1 by 2. So it will be 14 divided by options Yeah, options are quite close, right? So I'm keeping it as 9.8 only. So if we simplify this, so this will be 2, it will be 1.4. So that will be 0.7, and it will be 1 upon 3.5, 10, 2 by 7. So 2 by 7 times 2 will be the answer, 4 by 7, which will be 0.57. So option 3 is the right answer. Right, so now let us see the next problem type, which is based on angular momentum of a point particle. A body of mass 5 kg moving with a uniform speed of 3 root 2 meters per second in xy plane along the line y equals to x plus 4. The angular momentum of the particle about the origin will be. So we know that the angular momentum of a point particle about a point will be r cross p, where p is the linear momentum and r is the position vector of the particle with respect to the point about which we want to find the angular momentum. So first of all, let us draw the diagram or the line of motion. So this is y-axis, this is x-axis, and the slope is 1 and the y-intercept is plus 4. So let us say this is 0 comma 4, and this is the line of motion. So particle is moving along this line and the speed is 3 root 2 meters per second. So angular momentum can also be written as r perpendicular times the linear momentum, where r perpendicular is the component of r vector which is perpendicular to the linear momentum. Or we can also write this as p perpendicular time r, where p perpendicular is the component of linear momentum which is perpendicular to r vector. So let us say the particle is at this particular position and it is going in this direction with a speed of 3 root 2 meters per second. Its mass is 5 kilograms. And we want to find the angular momentum about origin. So if I draw the position vector, so that will be the position vector of the particle. So r perpendicular, the component of r which is perpendicular to linear momentum will be the perpendicular distance of the origin from the line of motion. So that will be r perpendicular. So this is 90 degree, and obviously this angle will be 45 degree, and this length is 4. So we can find r perpendicular, which will be 4 sine 45 degree, which can be written as 4 times 1 by root 2, or it will be 2 root 2 meters. So the angular momentum will be r perpendicular 2 root 2 times mass times the velocity. So this comes out to be 4 times 15, so it comes out to be 16 kilogram meter square second inverse. So 60 is the answer. Right, so let us this question. A body of mass m is projected with a speed u making an angle 45 degree with the ground. The angular momentum of the body about the point of projection at the highest point is expressed as root 2 mu cube upon xg. We have to find the value of x. Right, so let me first draw the diagram. So there is a particle of mass m and we have projected this particle with initial velocity u, and the angle of projection is 45 degree. And when this particle reaches at the highest position, and we know that at the highest position the velocity is u cos theta, so that will be u cos 45 degree. At this instant we have to find the angular momentum about the point of projection. So this will be the r vector. So we can say that is the component of r vector which is perpendicular to linear momentum. So r perpendicular is the maximum height attained by the projectile, and which is nothing but u square sine square 45 by 2g. So that will be u square times 1 by 2 by 2g, or we can write this as u square by 4g. So the angular momentum will be r perpendicular times linear momentum. So r perpendicular is u square by 4g, and linear momentum will be mass times the velocity at the highest point, which is u by root 2. So if I simplify this, let me rationalize the denominator. So we'll get root 2 in the numerator. So this will be mu cube times root 2 divided by 8g. So if we compare, x comes out to be 8. So 8 is the answer. Right, so let us see this question based on the same concept. A particle of mass m projected with a speed u, making an angle 30 degree with the horizontal. The magnitude of the angular momentum of the projectile about the point of projection when the particle is at the maximum height. Same question. So I'm keeping this question as a homework. If you solve this, you will get option 1 as the answer. Right, so the position vector of 1 kg object is 3 I cap minus j cap, and its velocity is 3 j cap plus k cap. The magnitude of its angular momentum is root x Newton meter. So where x is, so we have to find the value of x. So angular momentum will be r cross p, and p is mass times the velocity, and mass is 1 kilogram, so it is nothing but 3 j cap plus k cap kilogram meter per second. So let us substitute the values. So r is 3 I cap minus j cap cross with 3 j cap plus k cap. So it will be 9 k cap minus 3 j cap and minus I cap. Right, and we have to find the magnitude. So magnitude will be root of 9 square plus 3 square plus 1 square. So that will be 81 plus 9 plus 1. So that will be root 91, which is given as root x. So x comes out to be 91. So we got the answer. 91 is the answer. Right, so let us see this question. A mass m hangs on a massless rod of length L, which rotates at a constant frequency. So basically it is rotating just like a conical pendulum. The mass m moves with a steady speed in a circular path of a constant radius. Assuming that the system is in a steady circular motion with a constant angular velocity, the angular momentum about the point A is LA, which lies in a positive z direction, and the angular momentum of m about B is LB, the correct statement for this system. So let me first draw the diagram correctly. So here a particle is moving in a horizontal circle, and this is a massless rod, and this is the particle, right? So that is the axis of rotation of the particle. So if we find the angular momentum about point A, the r vector will be this, and linear momentum, let us say it is rotating like this. So linear momentum will be towards you or towards us. So so it will be in the z direction. So LA will be in the z direction. Let us call this as z axis. So L can be written as, L vector can be written as r times mv, and that will be in k cap. So angular momentum about A is constant. It is having a constant it has a fixed direction, and the magnitude is also constant because it is moving with the same constant angular velocity. Right, so let us see what is the angular momentum with respect to the point B. So with respect to the point B, the position vector will be this length, right? And if I apply r cross P, so it comes out to be perpendicular to the r vector and perpendicular to the linear velocity. So that is the direction of the angular momentum would be. So as this particle rotates, let us say this particle reaches at the right extreme. In that case, the angular momentum direction will also rotate, and it will be in this direction. But the magnitude will not change because r perpendicular doesn't changes, right? So the magnitude will not change, but the direction is changing. So let us see the option. LA and LB are both constant in magnitude and direction, so this is incorrect. LA has a constant direction and the constant magnitude, but LB has a different direction. So LB is constant in direction with varying magnitude. So LB, no, that is incorrect. It has a different direction. Direction is changing, but the magnitude is constant. LB is constant, so that is incorrect, because if the direction of the vector changes, the vector itself changes. LA is constant both in magnitude and direction, so that is correct. So option 4 is the right answer. Right, so let us see this question. A particle of mass 100 grams is projected at the time t equals to 0 with the speed of 20 meters per second at an angle of 45 degree to the horizontal as shown in the figure. The magnitude of the angular momentum of the particle about the starting point at time t equals to 2 seconds is found to be root k kilogram meter square per second. So the value of k, right? So how to do that at a general time? So time is given as 2 seconds. So we know that angular momentum will be given as r cross mv, or we can write this as r cross v times m. So if we are able to find the position vector of the particle and the velocity of the particle at time t equals to 2 seconds, then by taking the cross product of this r cross v, we'll be able to find the angular momentum. So let us find the velocity first. So we know that in case of a projectile motion, v can be written as u cos theta I cap plus u sin theta minus gt j cap. So let us substitute the value. U is given as 20, cos theta is 1 by root 2. So this will be 10 root 2 I cap, and similarly u sin theta is again 10 root 2 minus g is 10 and time is 2 seconds. So it will become 10 root 2 I cap plus 10 root 2 minus 20 j cap. So we got the velocity at time t equals to 2 seconds. Now let us find the position vector. So position vector will be x I cap plus y j cap, where let us say the particle reaches at point P, which has coordinates x comma y. So x can be written as u cos theta times t, and y can be written as u sin theta t minus half g t square j cap. So let us put the values. So this will become 10 root 2 times 2 plus 10 root 2 times 2 minus 5 times 4. So this comes out to be 20 root 2 I cap plus 20 root 2 minus 20 j cap. Right, so we got the position vector and the velocity. So let us take the cross product of r and v. So we have 20 root 2 I cap plus 20 root 2 minus 20 j cap, its cross product with 10 root 2 I cap plus 10 root 2 minus 20 j cap. So it will be I cross j will be k, so it will be 20 root 2 times 10 root 2 minus 20, that will be that will be k cap, and j cross I will be minus k, so minus of 10 root 2 times 20 root 2 minus 20. Now that is r cross v, and if we multiply r cross v with mass is 100 grams, so it is 0.1, we will get the angular momentum. So let us find that. So let me take the common thing. So 10 root 2 we can take common, so 10 root 2 times 0.1, and this will become 2 it will be 20 root 2 minus 40 minus 20 root 2 plus 20. So let us simplify this. So 20 root 2 will get cancelled out. So it will be 20 minus 40, that will be minus 20. So that will be root 2 times minus 20. So it comes out to be 20 root 2. And this is given as root k. So if I take the square, so that will be 400 times 2, that will be k. So k comes out to be 800. So 800 is the answer, right? Okay, so we are getting a negative minus k cap, right? So the reason for that is it will be in the negative z direction. Right, so let us see this question. A particle of mass m is moving in time t on the trajectory given by this equation, where alpha and beta are dimensionless constants. The angular momentum of the particle becomes the same as it was for t equals to 0 and at the time t equals to, okay, right. So there is no change in the angular momentum at t equals to 0 and t equals to t. So let me first find the angular momentum. So r cross m, let me take m outside, mv. So v can be written as dr by dt. So that will be, so if I differentiate this, the differentiation of t square will be 2t. So that will be 2 alpha t I cap. And this will become, differentiation of t will be 1. So it will be plus 5 beta j cap, because the differentiation of 5 will be 0. So we got the velocity. Let us take the cross product of r and v. So m times r is 10 alpha t square I cap plus 5 beta t minus 5 j cap. It's cross with 20 alpha t plus 5 beta j cap. Let us take the cross. So I cross, this is I cap, sorry. This is I cap and this is j cap. So I cross j will be k. So it will be 50 alpha beta t square k cap, and j cross I will be minus k. So minus 100 alpha beta t times t minus 5. Right, and this will be in k cap direction m. So this comes out to be so at t equals to 0, angular momentum is 0, right? So if I take, so we can say the angular momentum, so let us take 50 alpha beta common, 50 alpha beta and t common. So this will become t minus 2 times t minus 5. So we can say at t equals to 0, angular momentum is 0. And if so, let us say, let us find the value of t at which the angular momentum becomes 0. So when L is 0, then we can say t minus 2 times t minus 5 should also be 0. So this will be t minus 2t plus 10 equals to 0. So t will be 10 seconds. So we can say angular momentum will be 0 at t equals to 0 and t equals to 10 seconds. So 10 is the answer of this question. Now let us see the angular momentum of a rigid body. So if there is a rigid body which is rotating about a fixed axis, then its angular momentum is given as I omega, where I is the moment of inertia of the body about the axis of rotation and omega is the angular velocity about the same axis. A solid sphere of mass 500 grams and radius 5 centimeter is rotated about one of its diameter with an angular speed of 100 radians per second. If the moment of inertia of the sphere about its tangent is x into 10 raised per minus 2 times its angular momentum is okay, right? So it says about its diameter, then the value of x will be. So moment of inertia, so we have given a solid sphere and the moment of inertia about the axis which is tangent to the sphere, which we know is 7 by 5 mr square. Now this is equals to x times 10 raised per minus 2 times its angular momentum about the diameter. So it will be, angular momentum will be, it will be 2 by 5 mr square times omega. So that is given. So mr square will get cancelled out, 5 will get cancelled out. So we have 7 equals to x times 10 raised per minus 2 times 2. Omega is given as 10. So that will be 100. So this will get cancelled out. This will give us 5. So x comes out to be 35, right? So 35 is the answer of this question. Now, the next concept is based on conservation of angular momentum. So when do we conserve angular momentum? When the net torque on the system acting is 0. So consider a disk of mass 5 kg, radius 2 meters, rotating with an angular velocity of 10 radians per second about an axis perpendicular to the plane of the rotation. An identical disk is kept gently over the rotating disk along the same axis. So now we have placed a disk which is not rotating, right, over it. And due to the frictional force, after some time, both the disks will start rotating with the same angular velocity. The energy dissipated so that both the disk and this frictional force will be internal to the system, so anyway its torque will eventually get cancelled out about the axis of rotation. So that the energy dissipated so that both the disk continues to rotate together without slipping. So let us see. So we have given this disk which is rotating with an angular velocity omega. Now we have coupled this disk with another disk which is not rotating. We have just placed that disk over it. So that is the first disk which is rotating with an angular velocity of 10 radians per second. Its mass is given as 5 kg. Now we have placed another disk over it. And after some time, both the disks start rotating with a new angular velocity. Let us say the new angular velocity is omega, and now the moment of inertia will become double, right? So here the moment of inertia is mr square by 2. Here it will become mr square because we have identical disks. So here we can apply I1 omega 1 equals to I2 omega 2. So I1 is mr square by 2 times 10. I2 will be mr square, and omega 2 we have to calculate. So this will get cancelled. So omega 2 will become 5 radians per second. But we have to find the energy dissipated. So energy dissipated is nothing but the loss in kinetic energy of the system. So what is the loss? So we can say initial kinetic energy minus the final kinetic energy. So initial kinetic energy will be half I, which will be mr square by 2, omega square, that will be 10 square, minus half I omega square, that will be 5 square. So let us substitute the values. So mr square will be common. So I'm taking mr square by 2 as common. So that will be 100 by 250 minus 25. So let us, so 25. So we got 25 by 2 mr square. 25 by 2 mr square, m is 5, r is 2, so that will be 4. So this will give us 2. So it comes out to be 250 joules, right? So that is the dissipation. So that much amount of energy will be dissipated. Right. So let us this question. Same problem type. Two disk of moment of inertia I1 which is 4 kilogram meter square, I2 is 2 kilogram meter square about their central axis and normal to their plane, rotating with an angular speed of 10 radians per second and 4 radians per second respectively, are brought to in contact face to face with their axis of rotation coincident. The loss in kinetic energy, same question. Here basically we are coupling them. Now they both have initial angular velocity. So here what we can say, I1 omega 1 plus I2 omega 2, and I'm assuming both the disks are rotating in the same direction. So in that case you can add them up. So I1 omega 1 plus I2 omega 2 will be I1 plus I2 times the new omega. So we can use this and we can get the final angular velocity. So it will be 4 times 10 plus 2 times 4 equals to 4 plus 2 times omega. So 40 plus 8, 48 divided by 6. So that will be 8 radians per second. So that is omega, the new omega. And we have to find the loss in kinetic energy. So the initial kinetic energy will be half I1 omega 1 square plus half I2 omega 2 square. And the final kinetic energy will be half I1 plus I2 omega square. So let us find the values. So half will be common. I1 is 4, omega 1 is 10, so that will be 100. I2 is 2, omega 2 is 4, so this will be 16. So this will be 2, this will get cancelled, so 216. And final kinetic energy will be half 4 plus 2 times the new omega, that will become 64. So this will be 32. So we got 6 into 32. So that will be 12,192. So the loss will be K initial minus K final, which will be 216 minus 192 joules. And it will be 16 plus 8, that will be 24 joules. So 24 is the answer. Right. So another question based on conservation of angular momentum. If a radius of the earth is reduced to 3/4 of its present value without changing the mass, then the value of the duration of the day of earth will be dash hours 30 minutes. Right. So let us see. So in such questions we have to treat earth like a uniform solid sphere, and we know in case of a uniform solid sphere the moment of inertia is 2 by 5 mr square. So as we have changed the radius, obviously moment of inertia will change. So here we have to apply, and we have to find the time, and omega is nothing but 2 pi by the time period. So we can say I omega will be constant in this case, and omega can be written as 2 pi by t, so we can say I by t will be constant, right? So we can say I2 by I1 will be t2 by t1, so that we can do. So here we have to find the time period. So t2 will be t1 times I2 by I1. So as we make the radius reduce to 3/4 of its present value, and we know that the moment of inertia is directly proportional to square of the radius. So here we can write I2 by I1 as R2 square by R1 square, and T1 is 24 hours, and R2 is 3/4 of R1. So T2 will become 24 times 9 by 16, or I can write this as 3 and this as 2. So it will be 27 by 2 hours, or I can write this as 26 by 2 plus 1 by 2. So that will be 13 hours plus 0.5 hours. And 0.5 hours is nothing but 30 minutes, right? So it will be 13 hours, 30 minutes. Right, so let us see this question. A thin circular disk of mass m and radius r is rotating in a horizontal plane about an axis passing through its center and perpendicular to its plane with an angular velocity omega. If another disk of same dimension but of mass m by 2 is placed gently on the first disk coaxially, then the new angular velocity of the system. We have done similar question, right? So I'm keeping this as a homework. If you try to solve this, you will get option 3 as the answer. Right, so if the earth suddenly shrinks to 1/64th of its original volume with its mass remaining same, the period of rotation of the earth becomes 24 by x hours, the value of x. Similar question we have done. Here they have they are changing the volume. If they change the volume, obviously radius will also change, keeping the mass same, right? So they are keeping so density, mass is remaining same, the same concept. So if you try to solve, you'll get answer as 16. Okay, a circular plate is rotating in a horizontal plane about an axis passing through its center and perpendicular to the plate. With an angular velocity omega, a person sits at the center, have two dumbbells in his hand. So we have given a circular plate. We can treat circular plate like a disc. And there is a person at the center. He is holding a dumbbells in his hand. When he stretches the arm, so let's say initially the dumbbells were like this, right? So when he stretches out his arms, the moment of inertia of the system becomes triple. So for this particular system, the moment of inertia becomes 3 times. So it becomes from I to 3I. If E be the initial kinetic energy of the system, then the final kinetic energy of the system will be. So what will happen in this case? Moment of inertia becomes 3 times, and if I apply an like momentum conservation, I1 omega 1 will be equals to I2 omega 2. As the moment of inertia becomes 3 times, angular velocity will become 1/3. Right? So we have to find E. E be the initial kinetic energy of the system, then the final kinetic energy we have to calculate. So here we can say omega 2 will be I upon 3I times omega, that will be omega by 3. So we got the final angular velocity. So the final kinetic energy will be half 3I omega by 3 square, which will be 3 upon 3 by 2 times 9 I omega square. So that will be 3. Now what is the initial kinetic energy, which is E, and that will be half I omega square. So we can say I omega square is nothing but 2 times E. So this can be written as 1 by 6 times 2E, which is E by 3. So here x will be 3, right? Right, so let us see this question. A thin circular ring of mass m and radius r is rotating with a constant angular velocity 2 radians per second in a horizontal plane about an axis vertical to its plane and passing through the center of the ring. If two objects, each of mass m, be attached gently to the opposite end of the diameter of the ring will then rotate with the angular velocity. So again, a typical question of conservation of angular momentum. So we have given a circular ring which is having a mass m and radius is r, and it is rotating with an angular velocity 2 radians per second. Now what we have done, we have attached two point masses at diametrically opposite ends, each having mass small m. Due to this, the moment of inertia of the system will increase, and by the conservation of angular momentum, if moment of inertia increases, angular velocity will decrease about the axis of rotation. So let us, the new angular velocity is omega. So we can say the initial angular momentum will be m r square omega. That is the, because it's a ring, so moment of inertia will be mr square. So, and the final angular momentum will be moment of inertia of the system. It will be capital mr square plus 2 times mr square. So mr square, small mr square is the moment of inertia of one particle about the axis multiplied with omega. So r square will get cancelled out. So it will be 2 times capital M divided by capital M plus 2 times small m. And right, so omega is 2 na, so right, so it will be 2m upon m plus 2m. So option C is the right answer. Okay, let us see this question. A thin circular ring of mass m and radius r is rotating about its axis with the angular velocity omega. Two particle, similar question, right? I'm keeping this as a homework. If you try to solve, you'll get option 3 as the answer, right? A spherical shell of mass 1 kg, mass and radius r is rolling with an angular speed omega on a horizontal plane. The magnitude of the angular momentum of the shell about the origin is a by 3 times r square omega. The value of a, right? So it's a combined motion. So in case of a combined motion, we want to find the angular momentum about O. So what we're going to do, angular momentum about O can be written as, first the angular momentum, if we consider this body just like a point mass concentrated at its center, so it will be r cross m velocity of the center of mass plus we if we and the angular momentum of this body about the axis passing through its center of mass, that will be I omega, right? So we have to use this. So if we consider this body just like a point mass which is going in the forward direction, and we have given it is rolling, and omega is given, so we will be r omega. So there is a point mass m, and that is the position vector r. So its angular momentum will be nothing but this will be the r perpendicular, right? R perpendicular will be radius of this shell. So we can say it will be m r perpendicular times r omega, right? mvr. So this is the first part, and if we consider rotation about its axis passing through the center, in that case we have to use I omega. So it will be m r perpendicular, which m r perpendicular is nothing but r only, right? So that will be m r square omega. So m r square omega plus I omega, and I for a shell will be 2 by 3 m r square. So that should be the angular momentum, and you should also pay extra like focus on the direction. So this will be into the plane. So the first term will be into the plane, and the second term is also into the plane. So we can simply add them. So it comes out to be 5 by 3 m r square omega, and this is given as a by 3 r square omega. So r square omega will get cancelled out. Mass is given as 1, so it will become 5. So 5, so option C is the right answer. Right, so let us say this question. A rod of mass m and length L is lying on a horizontal frictionless surface. A particle of mass m traveling along the surface hits at one end of the rod with a velocity u in the direction perpendicular to the rod. The collision is completely elastic. After collision, particle comes to rest. the ratio of masses m by capital M is 1 by x, the value of x will be. Okay, let us see. So we have given a horizontal frictionless surface, and there is a rod which is having a mass capital M and length is L. Now there is a particle which is hitting normally to this rod at the end, at one of its ends. Let us say this end is A, this end is B, and the particle is hitting at the end B, and its velocity is u. The particle is having a mass small m. The collision is completely elastic. So when we have an elastic collision, right, so in this case, the rod is not hinged anywhere, so we can conserve linear momentum, and we can also conserve angular momentum about any point in this case, right, so and we have to find the ratio of masses, and particle comes to rest after collision. So let us see what we have given. So due to the collision, the particle comes to rest, and the center of mass will be having a velocity v in the right direction, and it will be having an angular velocity omega about the axis passing through the center of the rod. So if we conserve linear momentum, we can say m times u, that is the momentum before collision. After that, it will become capital M times v, right? And now let us conserve angular momentum about any point. So let me take this particular point which is at the same level as the center of the rod. So with respect to this point, the angular momentum of the particle will be mu L by 2, and its direction will be normal to the plane. So it will be mu L by 2 because this perpendicular distance is L by 2. And after that, after collision, again the rod is in a combined motion, but if you consider this first term, right, this first term will become 0 because r vector and v vector are parallel to each other, so first term will become 0, and then we are left with only the second term, and even in this case I omega comes out to be normal to the plane, and I will be capital M L square by 12 times omega. So from this L will get cancelled out, we'll get 6 here, so it will be mu is equals to capital M by 6 times L omega, right? Now the third thing what we can do in this case, we need to find in elastic collision the coefficient of restitution will be 1, or we can say the velocity of approach is equals to velocity of separation along the line of impact. So here let me show you. Let us, this is the rod and the particle is coming. So the velocity of approach will be u, and velocity of separation will be what? So at this point after collision will be having a velocity v plus L by 2 omega, right? So v is the translational velocity and L by 2 omega is the rotational velocity. So v plus L by 2 is the velocity of separation. So v plus L by 2 omega will be equals to the velocity of approach u, and we have to find the ratio of masses. So what we can do, let us find v u is right, let us find omega and u or v in terms of u, right? So v in terms, so omega will be 6 mu by capital M L. So let me substitute here. So v plus L by 2, omega will be 6 times small mu divided by capital M times L. So L will get cancelled out, this will give us 3, and it will be equals to u. So from this we can say v can be written as u minus 3 m by capital M times u, right? Now, and we know that v by u from this equation is small m upon capital M. So v by u will be small m upon capital M, that will be equals to 1 minus 3 small m upon capital M. Now from this we can say 4 times small m upon capital M will be equals to 1. So small m upon capital M will be 1 by 4. So x will be 4. So I hope this is clear, right? Not a easy question. So here I conclude this video and I try to make it as short as possible, but since it's a huge chapter, so I end up making it more than 4 hours long. So if you watch this video till end, you'll be able to answer 1 or 2 questions which can be asked from these chapters. If you find videos of this series useful, so it is highly recommended for you to join PracBee's revision program. So in this program, we're going to cover 10 blocks in 10 weeks, and we'll give you a target of 1 chapter per day, and we'll be able to cover all relevant chapters by the first attempt of JEE Mains. And how you can join this revision program? By clicking on the link given in the description. And one more thing you can do, please drop a comment. Let us know what else we can do for you to make this series better. Thank you.